Hello, everyone. Good morning. Amazing. No. What am I touching? There we go. Clap, please. Thank you. Thank you. Thank you. So for those of you that are wondering what the heck is going on, welcome to the IPFS community. This is actually from an account on Blue Sky called IFPS.tech. We don't know who this is, or at least I don't know who this is. This person may walk amongst us, we don't know. This little joke, and again, like if you're like, I don't understand what's going on, many of us also, well, still don't know what's going on. And this is content identifiers V0, which starts with QM, and content identifiers V1, which all start with BAFI. So you may have seen these QM hash codes in the wild, but the community generally is moving towards these BAFI ones. But why? And that's some of the things that we'll learn here. Ask your neighbor to explain BAFI today. Exactly. So welcome to IPFS Connect Istanbul. This is the first regional IPFS event, a gathering of the IPFS community, builders, users, protocol enthusiasts, organized by the team at Fission and supported by Protocol Labs. My name is Boris Mann. I'm the CEO and founder of Fission, and thank you, and a longtime member of the IPFS community. So we stuck up our hands and said, we'd like to organize one of the first community events. Tons of support from Protocol Labs in doing it, and in ideally setting things up so that we have other regional events. So if you're, can someone mention a hometown? IPFS Connect Vancouver, IPFS Connect Seattle, IPFS Connect Mannheim, IPFS Connect Princeton. So in the past, I've been involved in communities like Barcamp, or the Drupal open source CMS that has Drupal Camp. Obviously, IPFS has its IPFS Camp, and the regional version of what we'd like to see happen and grow is IPFS Connect. So in this particular one, we're focused on not so much the geographic region, but the fact that the entire Web3 community has thousands of people here in town connecting and interconnecting, and IPFS is one of those things that that basically connects through all of these things. I do want to say a special thanks to the Lab Week event team, as well as Uni and Nicole, who've done so much work with IPFS Thing and Camp, who aren't here today. Thank you so much. I know many of us have benefited from their great work in the past. So IPFS is universal content addressing layer. I'm still excited about IPFS and about content addressing, right? It's used across Web3 and DWeb, and the benefits of content addressing and self-verifying data is becoming clear even across Web2. It's really exciting to see various projects go like, oh, yes, it would be extremely useful to have a content addressable store. We've got a few things left to work on. High quality servers, libraries, and apps that everyone from builders to end users can build on and extend. Not just code, documentation, examples, and regional communities supporting each other. I think this last one is the one that's really interesting. I was really intrigued by the entire concept of an IPFS network of content addressing that was this soon-to-be interplanetary namespace that anything could be referenced. We've got the Amino public IPFS network, and we're soon going to have many more. For instance, my friends at Quiet run a chat app that transfers everything over their own private IPFS network, tunneled over Tor. That's a separate network, but uses that same sorts of things. Some of these networks will connect with each other, some of them will be special purpose. We should welcome all of our IPFS network friends. My personal mission that I've been jazzed about for the last 20 years and really got reinvigorated in connecting with IPFS is make it so that every human on the planet can put content online effectively for free, effectively forever. And this is where a lot of people go, oh, there's like incentives and this is complicated, and you know that IPFS doesn't actually store files, right? I do, but content addressing actually gives us the ability to share. If you have the content, it means you can reconstruct the content address and you don't have to ask permission to keep stuff around. You can stick it on a USB keep and throw it in a drawer, and 10 years later, plug it in again, and the math will continue to work. And that's really exciting. And I want to do more in looking at what it means to follow this mission. The flicker's fine. We love a flicker. There isn't one on the other side.
Okay.
Let's.
From the house? Okay, stand by from the house.
Don't use that. It's been burned. I need an extraction. So the Fission team took on organizing. We'll bring up other members of the team later. Protocol Labs committed early and said, yes, we will support this, and many of the teams are here. And we actually had a bunch of other teams in the extended IPFS ecosystem step up and help sponsor. So can the folks from Web3 Storage give a little wave of where they are in the room? Woo! Awesome. Saturn team. Woo! Number 0. Awesome. Tableland. Dataverse OS. Woo! Fenbushi Capital. Amazing. Thank you so much for supporting it, and thanks to all of you that bought tickets to attend. Ultimately, these are community events. We want to see them happen everywhere at various different sizes, and that'll mean working together, and that's one of the things we can do in collaborate on doing events and community together. Here we are. We've got the entire 7th floor, and we've got a full day of events. So you get your steps going here from Asuka. I'll be your host and MC in this room, and we're going to do 30-minute talks that will deep dive. So you can literally just grab a chair and stay here for the entire day, and you get a full set of things. A lot of the things in this room are going to be very application focused. What are we building on top, and how are we doing it? Genevieve Lucerne is at the other end near the entrance. That's the other theater room that's set up, and we have an entire day of 15-minute lightning talks that will blow your mind twice as fast as the 30-minute ones. Neuchâtel is the room that we transit through. So it's open here in the morning, all the big round tables there. Starting in the afternoon, we'll have 2 workshops, the Fission Everywhere computer workshop, and in the afternoon, the Saturn Web3 storage one. Feel free to grab space in there, transit through there. That's a hangout space. We're here to connect and work on stuff together. Zurich will have the IRO workshop, and as well as the Probe Lab team has hot topics on Web3 measurements. This is our space for the day. Connect, talk to each other, do demos, hack on stuff. Ask your friends about Baffy today. The other plug that I want to do at the very beginning is Daniel Norman here? Woo! Awesome. Thank you. Awesome IPFS is, how many of you have heard of awesome lists? Great. Awesome. Awesome lists are meant to be easy to maintain kind of information of lists of things that are awesome about various topics. So this is the one for the IPFS community. Add your project, file an issue, do a PR. We are focusing on open source code, workshops, tutorials, and things people can use. Say hi to Daniel about that. He recently revamped it and started working on it. A couple of us have maintainer rights. Become a maintainer. We'd love special topics. If there's an area that you're interested in, let's say you're interested in privacy, be great to get a selection of those. If you're in a particular region and you're like, oh, I totally know that there's 18 projects around IPFS in Mannheim, then became the maintainer for that. We're slowly going to start making it very clear that we're in this together, and the awesome list is an awesome example of that. Thank you so much, Daniel. Schedule is here. Everything you need should be at the main website or one click away from it at the end of the day. We've also got, outside of each of the room, we've got printed out schedules, so you can always look there about what's going on. And basically, I'm gonna wrap up here right now, and you're gonna pick your next adventure of where you're gonna head. So Brendan in Geneva, Lucerne. Brendan, can you stand up, please? Hello. So Brendan is the creator of IRO, and he's going to talk to us about taking IPFS to millions of new places. So head there. Stay here. Is Kyle in the room? Kyle from Brave Browser is here and is going to be walking us through what it means when we put the great tastes of browsers and IPFS together. Again, thank you so much for joining us today. We have an IPFS Connect account on Twitter. We're pretty much monitoring everything on all the networks. Please do share, think about what you're learning, and at the end of the day, we're going to come back together here and run a community session where we'll have an opportunity to make announcements, coordinate, see what we're going to work on, and really capture all of the learnings that we had today. Have an awesome day at IPFS Connect. Let's go. Follow Brendan to his room. IRO that way, Brave here. IRO or Brave?
I just changed my title slide because I forgot that's what I named it. So. I just made something up.
Do you need notes?
No.
You can do that?
Yeah, I'm just going to use the laptop.
Perfect.
Thank you. He just asked me if I was going to do notes. Instead, you guys get to hear me ramble for 30 minutes. So have fun with that. So yeah, as Boris mentioned, IPFS plus browsers. What's that mean? What's that look like? That's effectively what we're going to talk about today, and how we can turn the Web3 experience of a decentralized web into something that's more useful for Web2 people who don't understand this paradigm or understand its purpose. So a little bit about me. I currently work as a cryptographic security engineer at Brave. I focus mainly on Web3, so I'll do auditing of basically anything related to the Web3 wallet, related to IPFS, and in certain circumstances when we're implementing cryptographic protocols, I'll also do auditing of that. So, for example, our P3A protocol, where we have a cryptographic guarantee about k-anonymity, that's a project called STAR. Basically, I've done an audit of that as well. So, for me, I enjoy working on standards particularly. I've done this at W3C. More recently, I've worked on EIPs as well, and also follow some IETF and IRTF work. So done quite a bit of standards work, and previously worked on decentralized identity, and was a former editor of the verifiable credential spec. So I enjoy playing in both sides of the world of both technical and deep nitty-gritty engineering, but then also the political side of it. So if you need some information, there's that. Also, I do have a QR code for the slides. I have this on every slide because this is actually going to be an interactive demo if you guys want to participate. Also, as a note, if anybody has questions, feel free to raise your hand and interrupt me. This is not meant to be like a lecture for 30 minutes. It's actually much easier if you guys raise questions and ask me. Yeah, go ahead.
Would it be okay to tune out the link, or do you want it to be just in?
Yes, there it is. Yeah, go for it. I actually just made that in the past 5 minutes, so hopefully it works. If it doesn't, let me know. Cool, good to hear. I realized as I was sitting there that a QR code only works on your mobile phone probably, so that's why I had to stick a bit.ly link in there. So summary of the talk. Essentially what we'll do is we'll do a brief overview of the technologies first and kind of how everything fits in together. And then part 2, I'll do a demo of the technologies being used together. And then part 3, we'll actually work on deploying your own IPFS site. So let's jump ahead. I guess the first question talking about the concept is why. So essentially, content is way more enjoyable when it's easily accessible in a GUI. I think everybody's quite aware of this. And the web browser is probably one of the most ubiquitous GUIs available today to be able to access content. This is how the majority of the web is used. If you want to be able to use something like YouTube, people do that. They spend hours of their day doing that. Social media is the same way. Nobody's using their terminal to access Facebook. So with that, this is where we essentially need the idea of a content network. How do we pair it up with a ubiquitous GUI? Enter browsers. So with that, that's essentially the idea behind trying to integrate these things together and make it feel like it works just like the web does today. So a little bit about Brave. What makes Brave a Web3 browser? We've got multiple features that extend beyond the normal web browser itself. So if you think about the web today, most people think about what JavaScript APIs does Google Chrome and Mozilla ship. They think about what's HTML, how does that work? But when you think about Web3, you start to think about these additional patterns and additional technologies and capabilities that are built on that aren't enabled in Web 2 and enable new capabilities. So one of those is we have a built-in multi-chain wallet implemented directly in the browser. We actually support Filecoin in there. We also have built-in ENS, UD, SNS, and IPNS domain resolution. So in certain capabilities or certain cases with these, you can actually resolve an ENS name to a content identifier and then be able to register it, and we'll cover that. We also have Brave Rewards that pays user and BAT for opting into privacy-preserving ads. So this is kind of like the model. I'm sure many people are familiar with this. This is one of the key features of Web3 that got us into the space. Also, we have support for a full IPFS node built in. But by default, we actually mapped IPFS URLs to an HTTP IPFS gateway. The main reason for this is it's slightly different in terms of its privacy characteristics. And so being Brave, like one of the things that is our brand promise is trying to promise better privacy. Additionally, this also requires less storage constraints on the user device. So there's some trade-offs that will naturally come, but to me, that's what makes this such an interesting synergy between the two technologies, is if we say the web only works with HTTP, it doesn't necessarily make as much sense, whereas when we say the web works with content addressable networks, then it kind of changes the paradigm and forces people to consider, do I deploy to a server or do I deploy to a content addressable network, and what are the trade-offs I'm making? So what is IPFS? I might skip over this slide. I'm guessing the majority of people here know. Yeah, essentially at a high level, it's a content addressable network. You can consume content comparable to how DNS plus HTTP work is kind of the way that I was thinking about it when I was describing it. Content is hashed, and the hash is used to look up the content and find someone who has it. Rather than serving the content via HTTP IPFS nodes, it relies on libp2p to pass the data as well. So this is like essentially how the network itself works. And yeah, if you want to understand more, there's docs, but I'm pretty sure everybody here knows how to find those and probably has already viewed them. So how is IPFS used today? There's kind of the obvious answer of we share files between multiple parties. That's a very abstract term. Let's get a little bit more specific. It's used to host DApp front ends like Augur. So Augur is a prediction market. I actually don't know if it's still in use today, but the front end is still available. The contracts are still available as well, deployed on the networks. But if you show up at the app, the DApp, it doesn't actually work in the same way as if you showed up at another like random website. So there's other front ends as well. I actually just ported my blog post over to it, so you can do Web 2 content, you can do Web 3 content. There's the obvious answer of Tornado Cache. That's probably a little bit more politically sensitive. There's also, I saw the ability to be able to archive the web. And in certain cases, there are countries who mirror or who block Wikipedia, and so this offers the capability to be able to mirror that content and offer access to that information. So this creates new technology which then plays into different aspects of people's lives. And so that's what makes it very interesting. So part 2 is demo time. I'm going to go to uniswap.eth, and I just realized, back out of there. Okay, everybody seeing it? So this is a very interesting resolution, effectively. As you can see here, we're jumping over to an IPFS CID, and we have access to Uniswap. So why does this matter? So what ended up happening with Uniswap, I don't know if you guys have been following along. Uniswap has basically been regulated in a way that their lawyers have told them they can't launch certain tokens. There's a person in the community by the name Micah who's worked on Ethereum stuff for quite a while as an EIP editor, who basically took the front end, pulled out all their code where they restricted access to certain tokens, hooked it back up to the contracts, and connected it to a ENS domain, where it is able to actually resolve to a CID. So essentially, I'm now accessing a website with a URL domain that's being hosted on Ethereum, that's redirecting into Uniswap, and I'm now able to do something like make a swap. So connect to Brave Wallet. And we can do something like this. Connect. And at this point in time, I can basically swap my ETH for something like, let's say, DAI. So let's say I did. It's grabbing the prices, and I can go through and I can execute a transaction. This is a fully decentralized paradigm. There's no capability to really censor this in any sort of way. If the technologies underneath the hood do get censored, such as at RPC layers, what ends up happening is you can just point yourself at your own Ethereum node. So essentially what we're doing is we're creating a Web 2 paradigm of being able to access your traditional like dApps in a way that becomes uncensorable. And that's where this makes this in a very interesting way, but it's not only about the can we prevent the censorship technology, it's also about how do we deploy different capabilities and make different patterns, such as can I make this content available in better ways? Can I deploy it out to wider accessible areas when I'm offline, such as like being able to keep this content separate, signing the transaction, and then broadcasting it when I come back online. That's very similar to the concept of how secure scuttlebutt works. So there's a lot of different patterns that we actually are able to deploy from utilizing this that gives us new properties that are not available on the web. So that's the quick little demo. So what just happened? Essentially what happened is Brave browser detected a .eth decentralized TLD. When I typed in .eth, it recognized it and said, hey, I'm not going to resolve this over DNS. I'm going to instead use this other part of the code inside Brave core. And essentially what happened is it resolved the TLD via the built-in RPC service. So if my built-in configured RPC service is actually to Infura, then it's going to utilize Infura in order to make that call. In certain cases, if I am running a local Ethereum node or I'm pointing it in a different direction through Brave's configuration, then it'll resolve it through that RPC as well. Essentially what's happening is it's the RPC, it's contacting the RPC service, and then the RPC provider is pulling the information off the chain. And this is done through a read operation. So if you're unfamiliar with how ENS works, it's basically a NFT smart contract in a way. It was prior to NFT standardization, but it works in a very similar fashion where it does a lookup and reads that off the chain and then resolves back to a CID. So it's kind of like a mapping function in a way where you're taking that .eth domain and resolving that to a CID. Once it gets it back in Brave, parses the results and determines there's an IPFS record. So it sees the CID, or maybe it sees no record, similar to what happens when it goes to DNS, and it'll throw an error. Brave then performs a lookup on the IPFS record via a gateway or IPFS node. What you saw in the demo was me having it configured to the actual IPFS node. Finally, Brave renders the web page in a separate process, just like any web page. So this is where it becomes very interesting, is like, the harder part about this within browsers is the origin itself, which is a fancy way of saying URL. There's slightly different properties within browsers. They define it very specifically. Has very specific properties and security contexts. So for example, this is isolated to the IPFS CID. So local storage for the IPFS CID is set up separately than your access to your facebook.com local storage. So it's treated effectively just as another domain, or in this case, it's referred to as an origin. So this also means that it pops up all the normal browser security models. So you've got things like cores and secure context and all those capabilities. So you can actually still request for the permissions context of utilizing a camera. If you're running some sort of like front-end application that wants to be able to use the camera to be able to record a video or something. So this enables the capability to have a front-end service where you're recording a video, and then maybe what you do is you actually republish that video onto IPFS. Those capabilities and paradigms become possible all within the web browser. And so this dApp works similarly to one being hosted by an HTTPS server, but the backend architecture is slightly different. So this is the final step. Let's work on deploying our own. First, we'll have to install the proper dependencies, and then we'll need to build the website, and then we'll publish the site and view it in the browser. I've tried to pick a few very easy ways for you guys to be able to follow along. Can I get a show of hands real quick? Who actually wants to follow along versus who wants to just watch me do it? Show of hands of people who are going to follow along and do it. Do we got anybody? Got one. Cool. Got a few? Okay, cool. So if you have a separate website that you want to deploy, such as your own blog post like I did, let me know and we can go through a bit of a debugging session. If it gets a little bit too off topic, then we'll do it afterwards so that you can actually be able to get that done. But when you're actually deploying your own, 9 minutes? Cool, I can do that. Yeah, go ahead. Yes.
In this particular case, are they paying a pinning service, or is it just propagated because it's popular?
It depends on the service. So, for example, Uniswap Uncensored, somebody else is paying for that service and propagated, so it loaded very quickly. With my blog post, I was the only one who loaded it, so it took a little bit. And so what I actually did is I pinned it to my own local node, and that sped up the ability to be able to detect it. So it's probably paid, and then you run into how are you hosting it. So there's tools like Fleek that I heard about when I was setting up this demo that makes it possible to be able to put that on. But then there's also the ability to be able to just have the ephemeral aspect of it as well. So that trade-off of content availability actually makes a very interesting aspect of it, where it's traditional HTTP resources I believe, last I'd heard the stats, most web resources are only available for about 28 days in the current version of them, which is where Web Archive becomes very interesting. This actually offers the ability to, when you've deleted that content, to be certain that that content is never really available again unless somebody replicates it and pins it. So, does that answer your question? Okay.
Kyle?
Yep.
Another question over here.
Yep.
You mentioned Gateway, but is Brave browser also running a node in the app as well?
Yes.
Like a
So let me just show that real quick. So if you want to access this, you can go to Brave:IPFS internals. And then this is the way that I've accessed it. You can actually do the companion extension, and I've set that up as well. So essentially this button here, my node, links you out to the extension here in the same way. So I'm running a node on local as local host under port 45,002. This is my actual node. You can see the files that I have pinned here. It's my site that I was playing around with when I was actually setting up the demo. And so I can actually be able to access like this blog post that I've hosted now. I believe that my site is probably the only one that, or my node would be the only one that's hosting my site unless Fission node does some sort of replication on the back end in order to replicate those CIDs, because I use their tool and that's what we use in the demo.
So if I'm understanding you right, sorry, my throat's a little, if I'm understanding you right, if you have your Brave browser open, your node is running and your content is available to the world.
Yes, and this is where those privacy trade-offs come into play.
Okay.
So for example, if you're hosting content there, that IPFS, your IP address becomes available from running that node effectively. And so this is where you've got those settings. Actually, let me just go through the demo because I'm covering a lot of these things anyways. I was gonna go off on a tangent, but I realized I've already covered it in the slides, so. First part is dependency installation. So first we'll want to configure Brave properly by using a node rather than a gateway. This makes this easier to actually deploy this stuff. So the way in which we do this is we go to Brave settings/web3. And then once you're in here, there's a whole slew of IPFS configurations that you can actually set up. So you can change what your gateway is. You can change if you have default backup. You can do automatically redirect. So for example, if a site like IPFS.tech is already hosted on IPFS, it'll automatically redirect it to using IPFS rather than using HTTP. You can also install that extension through this IPFS companion. You can configure sizes, manage your keys, these types of things. So in this case, the default configuration, I believe, is actually ask. And essentially what happens is the first time you visit an IPFS site or a CID, it'll actually ask you, do you want to set up a node? Do you want to redirect to a gateway? Those types of things. This, again, comes down to the privacy considerations feature of if somebody's pulling in this content, then it now becomes possible that when they pull in that content and then it gets cached, their node is then actually re-replicating it back out to the rest of the IPFS network. And that IP address then basically becomes correlated with, hey, you viewed this site. So this is where that trade-off is. So in this case, we'll set it up to Brave local IPFS node, and that's where it just automatically sets everything up for you. Once we've got that, next we'll want to clone a website. I just did Wallet Uncon because I've been helping out with that. It was a public site. I was going to use IPFS Connect, and I couldn't find the website publicly. So you can also do this with any just random website. There's tons of configuration and capabilities to be able to do this with random Jekyll pages and any sort of like static markdown. The docs are fabulous for this, and I've got a link at the end to be able to see exactly in the docs where that information is. So we'll jump out to the terminal and hope this doesn't upset anything. Yep. So we're going to go to div. And we'll go here. And we'll do git clone. I've got to actually make mine SSH based just because that's how I have my git configured. Cool. How are we doing on time? 3 minutes. Okay. That's all right. You guys built a good tool to make this a little bit easier. I'll have to skip over the dependency of installation of Fission, though, in order to get there. On Mac, you can just run brew install, and you can actually install the tool, and then you can be able to make that work. I appear to be hitting an internet connection, so we're going to potentially audible this to something I've already got deployed. So I talked to you guys about my personal blog. So we'll go to personal here, and I've got this blog available. I've actually already got this configured. So now that I've got this site cloned, effectively what we're going to do as next steps is we're going to install this. Like I said, we'll skip over it. If you want to follow along, you can actually run the Fission suite and get the CLI tool. There's a link to that as well. If you have questions, feel free to grab me after. I don't want to put us behind at the very start of the day. So then we're effectively just going to build the site locally. The Fission CLI is built to work on more complex sites, like I mentioned. For the website that we'll use, we won't need to do any sort of additional build steps. So effectively, the way that we do this is that we go Fission setup. Mine should already be set up in this sort of case, so I don't need to execute any of that. We'll do Fission app register. And in this case, I'm already set up. Effectively, this is just going to redirect you out to your email so that you can link it, and then it'll all end up working. And then finally, you can do Fission app publish. And so because I have a YAML file already configured within here, which is what the register step will end up doing, it'll configure for you the capability to be able to actually publish this to an IPNS name that Fission sets up for you under a subdomain. So once this publishes, if I link out here, I'll be able to view the site on HTTPS, and mine's actually automatically redirecting to IPNS. And now you can see my blog post. This is the exact same thing as what you can see on HTTP. Same exact experience, but it's now hosted on IPFS. So that's it. The last piece of this is those links. For anybody who wants a copy of the slides, this is a good place to be able to find the links. There is actually the additional capability to be able to do your redirection to Web3 domains that are supported within Brave browser, like ENS, UD, SNS, and IPNS support. So I've linked out to that as well, which is kind of the follow-on of what you can do after this to be able to get to that uniswap/uncensored.eth TLD style. So. Time for a quick question, or? Okay. Any quick questions? Yes.
Excuse me, do you support Namecoin domains in Brave browser?
We do not. We have taken a look at quite a few different name resolution services. Namecoin, I don't believe we've looked at in a while. Handshake we've taken into consideration, as well as I know there's a few others that we've taken into consideration. And it really just comes down to engineering effort in order to support it and the number of like TLDs that are actually being hosted off it and stuff like that. We're definitely open to supporting others. We're not like tied to, you know, like any sort of like bias of which one's available. This is a part of the multi-chain experience. So, you know, it's really just about the engineering time and effort to add support for these other naming services.
Thank you.
Something to mention on that as well is we do care about long-term longevity of this. So some of the restrictions that we do set are things like if you're determining a TLD, are you actually going to work with ICANN, or are you causing namespace resolution conflicts and stuff like that? So if the eventual goal is we can integrate this into the web, we need to think about these types of things ahead of time, and that's one of the things that we're doing as like one of the leaders working on this stuff. So see, I'm a minute and 30 ahead, so I'm going to get off the stage.
So we've got a 15-minute coffee break right now. And then we'll be back in here with an amazing talk by Hannah Howard. Working IPFS Systems, a love war story, which I am really, really looking forward to. Kyle, that was amazing. I think the whole command line back to browser. I should give another pitch for just IPFS Desktop. If you haven't tried it, install it, and the experience would be take a folder full of HTML, drop it in, and it will work. And in some ways, I think that's one of the things to spread is the fact that it's here today. There's browsers that support it natively like Brave, and we should all be experimenting and doing more with it.
On the last slide, there's links to how to do it with IPFS docs for desktop and Fleek as well.
Amazing, good stuff. Coffee, snacks, see you back in 15 minutes.
Hannah, and I want to talk to you all about how we build IPFS systems that actually work. I've been working on IPFS systems I've been working on IPFS for about 5 years. This talk is sort of like my attempt to share what I've learned along the way. Sometimes these lessons that I think I maybe have learned are a bit painful. So maybe this talk will help you avoid some of that pain by sticking to best practices. All right, so strap in. It's going to be an adventure. Part 1, the dream. So how did we get here? Why are we all stressing ourselves out trying to make the whole internet use content addressing? Actually, first, how did you all get here? Why do you work on IPFS? No, seriously, why do you work on IPFS? Tell me. I'm going to actually ask 2 people in the audience to raise your hand and tell the whole audience why you work on IPFS. One over there. Yes, who are you? I don't recognize you.
Hi. So as I said at the beginning, I want to have any human on the planet to be able to put content online effectively for free, effectively forever.
That is pretty awesome. One more. I know a lot of you guys are working on IPFS right now. Tell me. I should have brought candy bars. I will bring candy bars next time.
Yeah, we got here because content addressing seems like a really great idea, and we would like to roll that up.
Yeah, content addressing. Looking up stuff by immutable, verifiable addresses that can enable us to know we got the right content, whether or not it is, no matter who it's from. That's pretty cool. Well, let me tell you, I know how I got here. And I want to show you some of my elite programming and research career that helped prepare me for IPFS. So first of all, I shipped a kick-ass inventory system to help the Gap send khakis to the world, right? Yes. I also shipped a kick-ass loan qualification app for our Wall Street friends over at Moody's, who somewhat famously rated all the mortgage-backed securities AAA. I killed it working on a website for a lesser-known Invisalign alternative, so that was pretty key. And I made the world a better place, and I made it a better place through an ESG investment platform for the young, liberal, and rich. And I worked on failed startups. Lots and lots of failed startups. Okay, but somewhere along the line, in my case, around about 2017, I was inspired. Like I imagine, as we just heard, a lot of you guys were inspired. Bizarrely, to me, this inspiration is captured pretty well on a TV show, Silicon Valley, and I'd like to play it for you. So let's see if this works. Hold on. Do we have audio? We'll find out. Sorry for the audio. Can you all hear that? Yeah? Okay. Let's see if this works. Okay. Oh, even better.
You've got unlimited time and resources. You can build anything in the world you want with your compression, anything at all. What's it going to be? 3, 2, 1, go.
No, I don't.
Go.
You said I have unlimited time.
Now.
A new internet.
What? Why?
Okay, well, I haven't really thought this through, so... Okay. I own a telescope.
Of course you do.
And I brought it out one night to look at the full moon.
Of course you did.
And I got to thinking, wow, we put a man on the moon using the computing power of a handheld calculator. And then I thought, okay, there's literally millions of times more computing power in my phone, and that's just sitting in my pocket, doing nothing, right? So then I thought, there's, what, billions of phones all around the world with the same computing power just sitting in people's pockets. So then I thought, what if we use all those phones to build a massive network. And here's the kicker. We use my compression algorithm to make everything small and efficient, to move things around. And if we could do it, we could build a completely decentralized version of our current internet with no firewalls, no tolls, no government regulation, no spying. Information would be totally free in every sense of the word.
You want to build a new internet.
Yes.
Richard, I like it. That I would.
Okay. Oh, it cuts off because there's literally no other part of this clip that I can play in a public audience. But if you want a hell of a laugh, I highly recommend going to look that clip up on the internet. It is freaking hilarious. But yeah, a new internet, right? Like something meaningful, something that like actually makes the world a better place, not just the slogan. Something we'd want our names attached to forever, right? So a lot of us set out building a new internet, and we built like a lot of things. We built IPFS. We came up with SIDS and libp2p and UnixFS and CAR and BitSwap and IPNS. And actually, each one of these is like a huge new specification and project. Like all of that is in IPLD. Yeah? Okay, wait. Then all of this is in libp2p. Yeah? Pretty amazing, like lots of stuff. Wait, actually SID is like 4 technologies alone, just SID. Plus, then if you're in Go, here's some like storage stuff we built. We built like, since you want to talk HTTP, we built 4 different types of HTTP gateways. And then there's like the services you got to build, pinning, providing. Heck, we actually built an entire Go module system at one point. Anybody remember GX? Am I really old? Okay, cool. Yeah, so, I'm part of the story too, because I wrote a bunch of this stuff. This is an abbreviated, like semi-accurate list of things I can point to and say, yeah, that was me, I did that. Yay, woohoo, woohoo. But yeah, here's the thing. We built all this, like it works. Like kind of. I mean, like, sorta. You know, which is to say not very much. We're getting there. So we have like all that stuff. Oh, I forgot to mention this thing. Sorry, I just need to make this point. All of this, like super easy to learn as a new developer, right? just a few things to pick up. I remember when I first started working on this, like the thing that shocked me was like the entire stack was built from scratch. Every single part of it was custom. It's kind of overwhelming. Anyway, cool. So if our protocols are struggling a bit, what are the protocols we're trying to replace? So these are the core protocols of the web, 4 of them, I think. You can run a web browser and a web server with just these 4. Am I wrong? I don't know. Maybe talk to me after if I've forgotten something critical. It seems simple, and like we have so many more names, right? So why haven't we won yet? Well, I would argue that we try to build an internet with protocols. And in fact, the company that even started a lot of this is called Protocol Labs. But the internet is not protocols. The internet is infrastructure, built infrastructure, like a whole lot of infrastructure. Part 2, trains. So if you don't mind, I'd like to take a brief detour and talk about another kind of infrastructure. Let's talk about building trains. The subway and light rail of a major American city. Anyone want to guess which one? Oh, how did you know that? Jesus. That is a major, awesome light rail system that looks pretty extensive, and it's in Los Angeles. Los Angeles has a pretty freaking large rail network, and we're building, like a lot. Everyone thinks we love our cars, but we pay a full cent of sales tax to build new trains. And that's a tax that we voted for. 2/3 of the city voted for to get a new tax pass so that we could build more trains. Which shows you that LA people believe in transit, but we don't actually use it. 73% of Angelenos drive alone to work, and 6.8% utilize public transit. So why? Well, for starters, we already have this. That's the LA roads. There are a lot of them. And once you build something, it's hard to do something different. Our roads cost a lot of money to maintain. Like that sales tax is really great, but about a third of it, as much as the rail, goes to highway construction and maintenance. And geographically, LA is a huge city. The rail network you saw might look pretty big, but it's not when you consider the number of square miles involved. Eventually we'll see buildings start to happen around these lines, but the city is already built. Nobody put the hotspots near the rails. And in fact, those are the places that it's hardest to build because the hotspot people don't like new construction interrupting their hotspots. So you realize that a typical distance from and to a rail stop is on the order of like miles. And everyone has cars. So you can take a rail stop, you can drive 15 minutes to take a 30-minute rail to take another 15-minute Uber to get where you're going, or you can take 30 minutes in a car, sometimes 45 with traffic. And it's not just the infrastructure, there's the infrastructure of culture. Like, we are known for our love of cars in Los Angeles. And there's a history to that, but that's where we are today. So, what lessons can we learn? First of all, it is harder to build, it's harder to change infrastructure than to build it for the first time. Infrastructure is not just what's built, it's what's built around it. And finally, infrastructure is habits and culture as well. Cool? All right, I just want to do one more rail thing, and then we'll move on. One more bit about trains. This is China's high-speed rail network. If you want to spend an interesting hour, just do a deep dive on this. China has built 40,000 kilometers of high-speed rail. That's larger than all the high-speed rail networks in the world combined. It transports about 2 million passengers a day at about 350 kilometers per hour. It's wild, and it's been built in less than 2 decades. Like, at the beginning of the 2000s, there was none of this, and now it is there. This is California high-speed rail. We approved it in California about 2 decades ago. It's not operational. It won't be done for real for at least a decade, probably more. When finished, it will move riders most of the way between Los Angeles and San Francisco at speeds of less than 200 kilometers per hour. So why is it different? Is it just, further evidence that America is a dying empire and its people have no shared purpose, or some, meta-existential thing like that? Well, look, Americans have built stuff. Like, that's our interstate highway system, which is actually larger than the Chinese high-speed rail system. And it was also built in just a couple decades, right? So we can build. But I think there's some more, here's 2 real reasons why I think this happens. First of all, there's a demand, right? And an incentive. Before high-speed rail, China didn't have infrastructure that scaled to its population, or transportation infrastructure. The high-speed rail is like an integral part of China's emergence as an economic superpower. So the system itself is super expensive to build, and it operates at a net loss. But when you factor in like the way it's changed the economy, it's an amazing rate of return. Somebody estimated about 6% annually. The system connects China's cities to the rural community so that rural folks can get into the cities, and it's enabled all these smaller cities to become economic hubs to rival the larger ones, because now there's a quick way to move between them. In the time it was built, almost half of China's population entered what economists call the middle income, sometimes called middle class, but I think probably not quite what we think of as middle class, but still, it's 1 billion people. It's like astonishing, right? US, on the other hand, has a road system. It has an air travel system. The California high-speed rail isn't built, will still be a huge economy, right? So infrastructure gets built when there's a need. And there's one other thing we have in California. We have bureaucracy. So if you do a deep dive on California high-speed rail, you will find that there's a few communities and a few local politicians managed to totally mess the whole project up by acting in very, very specific self-interests, either by not allowing the rail to go through their community where it clearly needed to go, or by demanding the rail go to their not very important community, mostly politicians, so that they could get, they could say, I brought the rail to our town. So yeah, there's that. So what we can get is that infrastructure is not just building objects, it's building consensus. Yeah? Meanwhile, China has the central government has basically been able to mandate this and move through. And that's not necessarily great. Similar to the US interstate highway system, right? If you go into the history of these things, they got built fast, and a lot of communities got messed up in the process. A lot of people got hurt in the process. So it's not to say that the one is better or worse, but you have to have consensus to move forward, and that's an important part of infrastructure. Okay, part 3, building blocks. So, what's the infrastructure of the internet? Well, for starters, it's a lot of computers and servers. There's a lot of switches and routers. This is a Verizon switch center. It's a hell of a lot of high bandwidth trunks. Literally trunks that are ironically a series of tubes. Al Gore was right. We have built a lot of tubes, and that is the internet. Those are some that go underneath the ocean. And if we take what we learned from trains, it's not just what we built, it's what we built around it. It's browsers, which are like highly complex, highly optimized software for reading the internet as a client. And it's web software like Apache and Nginx, a highly optimized software to serve the internet. And then it's not just that, it's standards bodies like the W3D, W3C, standards bodies that now have very vested interests involved. And finally, it's design philosophies. Mostly this guy's ideas. That's Roy Fielding, the creator of the REST architecture, which for many years I sort of like derided as theoretical mumbo jumbo, but it's actually the entire caching strategy of the internet. It's pretty awesome. It's basically what allows the thing to grow to be, web scale. So what do we got? So this is actually the part where I say we do have some infrastructure. Like, let's talk about what we got. Well, for one, we have 250,000 IPFS nodes. That's not nothing, right? We have, through Filecoin, we've actually built a ton of storage capacity. Like, we have a few exabytes of hard drives available that we could be using in some fashion. We have hundreds of us. Well, yes, hundreds of us here in Istanbul trying to build this, right? And we built community around it, and that's infrastructure, yeah? We have billions of dollars of investment that we have spent, sometimes not as wisely as we could have, but some other times, yes. And finally, we have 10 implementations of IPFS. So like, that's awesome, right? It seems like, so we've got a lot of building blocks, right? Oh wait, did we get one more thing? Oh yeah, we're even interplanetary, right? We have IPFS in space. But in any case, we've got a lot of infrastructure. The big thing is, what we don't have, that the web has, is a set of technologies that go together, right? So that people can build amazing applications on top of it, right? The things that the web has all work together such that people build things like Facebook and, I'm not going to go, Google, whatnot, that drive adoption of billions of people. And we need these things so that billions of regular people will start to use IPFS oftentimes without even knowing it. And for that, I want to put out a controversial idea. We don't actually need more technologies. What we really want is fewer technologies, but it should be tech that goes great together. Part 4, systems. So recently I saw a video from Brendan, who I think was the previous speaker, talking about IRO as an IPFS system. And I called him up afterwards, and we ended up having a debate because I was like, IRO is not an IPFS system, it's an IPFS implementation. And he argued that IPFS was not an implementation because it doesn't interoperate with Kubo, and I argued that, well, that's not what the specs say. We made them really open, so you don't have to interoperate. And we went back and forth for a bit, but then I started thinking about, wondering about systems, right? What IRO is a cherry-picked set of IPFS technologies, some old, many very new, that go together to form what I imagine Brendan is busy telling folks in the other room right now is a great platform to build on. So maybe what we need is not implementations, but systems, ways of putting the pieces together that enable highly scalable applications. And that gets to the core point of this talk. What IPFS systems have been built that you can really build amazing applications on top of. So, welcome to the Developer Love section of the talk. I'm doing free advertising for your company for most of the rest of this. but we're going to look at some systems. Let's start with the one we were just talking about, IRO. So IRO is, it's a very optimized software, right? It's written in Rust with an eye towards mobile, running on mobile. It has very limited data transfer and hashing. There's only one way to transfer data, and there's only one way to hash it. And they custom select it to work really well. It also has a very fixed network stack. It doesn't use libp2p, it just uses quick. The focus of IRO is to move and sync bytes and also collections of bytes, or basically like a key value store of bytes. And that's it. And what you get for all of this is, hopefully, Brandon convinced all of you that they've built a really amazing and scalable syncing platform for files that you could use for all kinds of stuff. It's almost like a Firebase alternative. It's not an app, it's a platform, but it works, right? I want to talk about another platform. Next thing I want to talk about, UCAN. So UCAN was developed originally at Fission, the folks who I think are the lead putter honors of this conference. And it was built out a lot also by Web3 storage. And what it is a system for essentially tracking chain of authority across an IPFS network, right? At its heart, UCAN is a simple JWT extension that essentially enables verifiable delegated authorization. It means a user can delegate some authority over their data to, it means the user can delegate some authority over their data to external parties, but in a limited and scoped way. It's like OAuth 2, but simpler. But it's kind of gone a step farther and built this whole concept of delegated invocation, the ability of users to allow services to run things for them, and then to actually get receipts that it was completed. And what you end up with is something really important. There's one more technology in the mix called DIDs, and when you mix them with UCAN, you get what Web3 storage has essentially built. You have the ability to hire arbitrary services to do work for you on the decentralized web. That's wild. I looked at did a deep dive into their technology, and I kept saying, where is your user database? And the actual reality is in their new platform, they don't have one, because the whole thing is delegated authorization starting right on the user's computer. And that's pretty amazing. Let me tell you about one more that I like. They're not here, but Banyan. Banyan is a platform for enterprise storage. But what it really is another technology from Fission, WinFS. WinFS used to encrypt user data, pack it, and set it up to be stored in large quantities. And all of that happens on the user's computer, so it's all private. And then they use a storage technology. In this case, they're actually just using Filecoin, right? To hold all the data. But they need to take it a step further because they want to offer a sort of great DX web UX experience. So they have custom storage software that they make their SPs run. And to make their SPs run that software and do a good job, all the SPs have to sign contracts with them. It's not just everybody gets to sign up. But the cool thing is, I think that they have built, or they're building, an enterprise grade working private storage system. It's pretty awesome. So finally, I want to tell you one more. This is a preview of the next talk, and it's also a shameless advertisement for something I work on. Yeah. So the last one is Saturn, right? Saturn is a decentralized content delivery network. And it builds using a combination of technologies, right? We use content addressing, that's IPFS, but we use it for a specific purpose because it actually unlocks a kind of a superpower for us, which is how I hope we think of content addressing. How can we actually use it to unlock amazing benefits for our users? We use, in Saturn, is an optimized IPFS fetching software. All it does is retrieve content from IPFS and do it the best ways we know possible. That runs inside of each Saturn server node. And then in the browser, we run some JS service workers to decrypt, no, not decrypt, wow, I wrote this at the very end, to verify IPFS content, not decrypt, no encryption involved, in the browser, so that the client software does not have to trust the server software. And then we have a crypto-economic model, a simple one, based on metrics, reconciliation, and between clients and servers. It actually does have orchestration software that is centralized to basically do all the fraud detection on those metrics. But what does all this unlock? You'll hear a lot about this in a second, but we've been managed to spin up a massive network of nodes in a short time that offer huge amounts of capacity and have served, a billion requests in a week. And that all is done because the network is decentralized and because content addressing allows us to build a network where we don't have to be the ones running the servers. So you'll hear more about that, so I'm not going to talk anymore. You probably are asking, maybe there's some downsides that are creeping in your head about these systems, and I don't know how I feel about this. Why are you starting to centralize? Uh-oh. Hey, these don't interoperate completely. Okay. There are trade-offs. There are trade-offs in these systems. Yeah, we're going to have to figure this out. And we also have to figure this out, and we have to stay focused on where we're trying to get, not just stop when we get something that works and gets a little traction. We do need to keep moving towards what we want to build. So how are we going to do that? Part 5, people. So this is just, this stuff is hard. There are trade-offs. Some of them are painful. So what do we need as a community to move forward? I'm going to just offer 3 things. First is humility. This is the one that I learned the hardest way. Yeah, we don't know what we're doing. None of us do. I don't know. Maybe some of you do, and if you're smart, like if you're one of those people, like congratulations to you that you have the vision, and then you can just see the future and go towards it. I'm not one of those people. Probably a lot of us aren't. And it's best to just acknowledge that. We're trying to figure stuff out. We don't have to claim it's all working right this second, as long as we're committed to making it work. The other one that I would encourage, and I've seen this across all of our teams, is that we have a culture of competition rather than a culture of listening. We all want to prove that we alone have the big fix, the set of cool things we can put together that will make our stuff, work awesome. And I don't think that's helpful. I just wish we would just take a minute, even the people who are doing the best stuff, take a minute and listen to what other people are doing and just be open-minded about it. Maybe there's something, yeah? And then of course, the last thing is just a little bit of patience, or a lot of patience. This is hard work, we're doing it together, and a little bit of trust for each other. We all have very strong intentions being here, right? Most of us, or a lot of us, could have jobs that were probably easier, potentially better compensating in, big tech companies doing traditional stuff. But we're all here because we're trying. And so I would encourage, assume positive intent, assume best intent, just trust each other, try to trust each other, which is hard. That's it. Lastly, just that's my contact information. These are some people people and dogs who are very important in my life, make it happy. That's Elaine and my dog, Sadie. And then that's my contact info. And that's the Saturn link. So that's all I got. Cool. And I got apparently 1 minute. 1 minute according to that for a question. That's it. Or you don't have to ask questions.
What's the name of your dog?
That is Sadie. The name of my dog is not Lassie, even though Lassie was a technology I worked a lot on. That's Sadie. That's Elaine. That's me. That logo is me if you see it. See that anywhere on the internet. It's the only drawing I've ever made that is half decent. So, yeah.
Thank you so much, Hannah. That's an amazing talk. I'm glad we got it on video. And I was tearing up at parts of it, seriously, including all the stuff that we've done. And I'm really glad that we've captured this. And, IPFS Connect. Let's humility, listen, work together. Thank you so much.
Okay. Somebody else take over. This isn't my computer, so.
Just walk off. Ansgar. Come on down. Yeah, you got this. Oh, candy bars. Oh,
We sure do.
nice.
Okay, good morning, ladies and gentlemen. My name is Ansgar, and for the next 20 or so minutes, we are going to dive headfirst into the wild, woolly, out-of-this-world world of Saturn. What is Saturn? Where is it? How is it built? How is it designed? And most importantly, where is it going? Saturn, like every great product, begins with a problem. Saturn's problem is, where is Web3 YouTube? YouTube, what is YouTube? It's an enormous pile of hardware and software, all tailored, designed, architected, and scaled to do one thing: to deliver bytes from them to you, to bring video from them to you. And the problem with Web3 right now is we cannot build a Web3 version of YouTube. The infrastructure required that runs YouTube does not exist in Web3. And chiefly, I keep slapping this thing, chiefly, I'm just so excited, chiefly amongst that infrastructure that's missing and omitted is delivery. That key aspect of YouTube of delivering bytes from them to you. That is what beget Saturn. Saturn is a decentralized, crypto-incentivized content delivery network. And we are going to tease that apart into the three different pieces. Let's start with the last one first, CDN, Content Delivery Network. What in the world is a content delivery network? The best way I can describe a content delivery network is pretend you're Amazon and you're delivering packages and parcels to the smiling denizens of the world. The way you build your logistics infrastructure at Amazon is you have a few enormous warehouses around the world. And these warehouses store all the goods that Amazon sells. But the problem is, if you don't live near one of these enormous Amazon warehouses, it becomes expensive and slow, often prohibitively, to order something from these warehouses. So what Amazon does, they have these enormous warehouses, but they have many smaller warehouses all around the world. And when you order your goods, you order your diapers or whatever else you may order from Amazon, your IPFS corgis, whatever else you order from Amazon, your order actually gets fulfilled by a much smaller warehouse, much more proximate and much closer to you. And it's that network of smaller warehouses that store a smaller amount of content but can deliver it to you much faster, much cheaper. That's what a content delivery network is on the internet. The giant warehouses, in the YouTube example, are where YouTube stores all the videos. When you upload a video, it's stored in a giant Google data center. But when you watch a video on YouTube, it doesn't come from one of those enormous data centers. It comes from a smaller data center and a smaller cache, faster and closer to you. So that is what a content delivery network is. It's a world-scale network of machines in small little clusters pushed as close to the edge, as close to the end users as possible. So that's what Saturn is fundamentally from a technical architecture. Decentralized. What does it mean that Saturn is a decentralized network? What this means for Saturn is trustless. Anyone can run a node, anyone can participate, and you don't need to trust the people running the software. It's verifiable, and that all content that you receive from the content delivery network can be verified locally. Again, this is the key piece that unlocks the trustless aspect. And the other key piece is that it's software. It is open source, anyone can contribute, anyone can download, anyone can use it, and anyone can modify. There's no central authority, there's no central control. And now the last piece, crypto incentivized. This is the magical thread that weaves it all together. If you want someone to do something incent them to do it. And Saturn is no different. To achieve a world-scale content delivery network with a team of 9 people, you need to incent others around the world to act and help the network grow and scale. And so all nodes and all participants in Saturn's network are incentivized to participate in good ways. And so far, if you run a Saturn node and you cache content and distribute content, you are incentivized and rewarded for doing a good job. In this case, you are remunerated for your contributions to the network in Filecoin. In layman's terms, you make money, you make bank. And so you're incentivized to help be a participant in the network. Now, what does Saturn actually look like? We've talked about at a high level what it is. What does the architecture look like? Show me the money, baby. So what we see over here is on the far left side, we see an application, and this could be an application in a web browser, this could be a native application, this could be some application running on a server, and the key piece inside thereof is the Saturn client. So just like you need an HTTP client to interoperate with the web, in this case the browser comes with an HTTP client, you use a client also to interact with the Saturn network. And what you do is when you need to fetch a piece of content from the Saturn network, you don't send it a URL like https://google.com/cat.ping. Instead, you request a SID, a content identifier that you guys are familiar with. And that SID comes back to be a critical piece, and we'll get there in a second. And what happens when you submit a request, the Saturn client routes you to that small Amazon warehouse near you. It routes you to a Saturn node around the world as close as possible. And what this means is this is how you gain not just scale around the world, but also performance, is your requests are routed to the closest nodes near you. And we'll get to a map of what Saturn looks like in a second, and we have nodes all over the world. And what this means is the key piece of a content delivery network, it's fast. Now, what does a Saturn node look like? A Saturn node has a singular responsibility. Fill as much disk as it can with stuff to cache, like in the Amazon warehouse analogy, as many toys and Barbie dolls as you can, and serve those as rapidly as possible to all the applications that request content from it. Now, below, we can see the orchestrator or control plane. This is software that underpins the entire network and is the glue that holds it all together. This is the software that sees when nodes join the network, when they leave the network, if a node is performing poorly, to lower its weight, to send fewer requests that way, when a node becomes overloaded, to also reduce the number of requests that flow its way. And it's also the piece of software which monitors the network for anomalies, fraud, and most importantly, it kind of calculates and monitors what nodes should be earning and their rewards that they should be remunerated with. And now finally, we see on the back end, IPFS and Filecoin. And so as Hannah mentioned, and as Hannah built, the Lassie software, that's the software that runs on the Saturn node that will fetch content from IPFS and Filecoin. So you can imagine that, like a cache, if you go to an Amazon warehouse and ask it for a Barbie doll, and that Barbie doll is not in the Amazon warehouse, that request is going to go all the way to one of the enormous data centers or enormous warehouses that has that. Our enormous warehouse and data center is IPFS and Filecoin. That's the bedrock of Saturn. So cache misses will flow out of a Saturn node into IPFS and Filecoin. So now let's dive into each of these components individually and get a better understanding of their roles, responsibilities in the Saturn network. So let's start with the application first. So one of the key facets of the Saturn client that runs inside of an application is what we call smart node selection. So Saturn is a large and growing network of nodes, over 2,200 of them as we speak today, as I speak now, around the world. And a key piece of this, and what gives Saturn its speed, is when a piece of content needs to be requested, you're routed to one of the nearest Saturn L1 nodes. And that way it can deliver the content you requested to you as quickly as possible. Another quintessential piece of the Saturn client is that it verifies content. And this is a key. This is a fundamental requisite key of how Saturn is built. Why? Because anyone can run a Saturn node, they could do whatever the hell they want in terms of delivering content to you. They could deliver the wrong content to you. They could do that either through malice or accident. So let's go through an example. Let's say you're building a website for your favorite puppies, like Sadie, is what we? Sadie, yeah, like Sadie. You're building a favorite website with pictures of Sadie, and you're using Saturn to do it, and someone comes to your website and they want to load a picture of Sadie. You send a request or a SID for a piece of content of Sadie, and it lands at the nearest L1 node. But that L1 node, either through malice or accident, could send you back a picture of a cat or a dog or some other dog that's not Sadie or anything else. How does the client know whether it received the content it requested or not? This is content verification. The client has the SID, and the content it receives back from the L1 is not the actual file, it's not the image, it's a CAR file, which is the file broken into lots of pieces along with the Merkle DAG of the hashes of all those pieces. And lo and behold, the SID that it originally requested is the root of that Merkle DAG. And so the Saturn Smart Client can incrementally verify bytes of that file as it's streamed back from the Saturn node, and insofar it doesn't have to trust the Saturn node. So the content verification is a key piece. Also, of course, just like any robust client, the Saturn client provides retrying, error verification, and all manner of things that you need to provide in a client for a robust network. And the last piece here is that the Saturn client also reports on L1 nodes. Every Saturn client is a set of eyeballs in the network that monitors the rest of the network, especially the network around it. And so let's say you're a Saturn client and you try and fetch a piece of content, you try and load a picture of Sadie, and you get back something else. Verification fails. But you should report that to the network because other nodes are likely going to be requesting content from the same Saturn L1. And so Saturn clients are the eyes of the network. They are all seeing eye and they see what happens in the behavior of all nodes and report that back to the orchestrator. Now, let's go one level up. Again, the Saturn nodes' primary responsibility is to cache content and serve content. These are the warehouses of the Saturn network. And again, what they serve is not flat files, as it's known, like it's not just the image file. They're these specialized CAR files. And the reason we use these CAR files is for verification. So clients can verify content as they receive it. And that's the piece that lets Saturn be a trustless network. Clients can verify, and Saturn nodes can send CAR files. Now, as we also mentioned in the prior diagram and architecture, Saturn nodes will cache miss to IPFS and Filecoin. So what does this mean? That all the content that you, as a user, through your Saturn client, would fetch from an L1 node, if it's available on IPFS or Filecoin, it can be served already, right now, by a Saturn node. And one other interesting key aspect of a Saturn node is every Saturn node has a weight. And what that weight is determined by a bunch of performance metrics, a blend of performance metrics. So there's metrics like TTFB, time to first byte, the total upload speed, the number of errors, the number of verifications that have failed. And all these metrics are put in a little cauldron and stirred and bubbling. And what comes out of that is a weight. And this is what you want to optimize if you're a Saturn client. The better your performance, again, we're talking about crypto incentivizations here, the better your performance, the larger your weight, the more requests you receive, and the more you earn. And if you're a bad node, the opposite happens. You receive a lower weight, you receive fewer requests, and you earn less Filecoin. And in this way, every node is incentivized to provide more faster to the network, and the crypto incentive cycle is completed. The last piece here is metrics. Just like Saturn clients report on what they see in the network, Saturn nodes also report what they see. They report the requests they send, they report metrics on their health, the amount of disks they have, et cetera. And all those metrics are reported, both go into the soup that kind of calculates their weights, as they're corroborated by nodes from Saturn clients, but also go into how many rewards they should be given. Now, the last piece here is the brain of the network. I like to think of this, if any of you guys are familiar with X-Men or have seen any X-Men movies, you have Professor Xavier and he puts on a Cerebro helmet and can see all minds in the world. This, the control plane, the orchestrator, that's Cerebro. And it sees all nodes in the network and monitors all nodes in the network. And when a node joins the network, it's what welcomes it with a red carpet rollout. And when a node leaves the network, it's what pats it on the butt out the door. You know, it manages the network. And one of its key responsibilities, as we talked about, every node has a weight. It's the control plane that sets weights of every node. So it rewards good behavior and disincentivizes bad behavior. It's in charge of routing, is how does a node get routed to? And it's also in charge of issuing and managing TLS certificates. And why are certificates important? Because they're a fundamental underpinning of how the web works. When your browser tries to load content from a secure web page, it's not going to let content be loaded from an insecure web server. So certificates are a key piece here, and the orchestrator is what manages that. Another key responsibility is it calculates rewards for Saturn nodes. So again, rewards fundamentally break down into how much content to deliver and what was the performance of that content. And the orchestrator sees all this, monitors all this, and calculates the rewards. Another key piece the orchestrator does is it detects anomalies and fraud. There is no proof of bandwidth exchange. There's no way to really stop two nodes from colluding and exchanging content in kind of an infinite loop to say, like, oh, hey, this node sent me 400 exabytes of data, please pay me in turn for 400 exabytes of data. So what the orchestrator does is it takes a look for and tries to find anomalous behavior and fraud and stamp that out. And the last piece that I do want to mention here is that the orchestrator right now is that we are engineers shipping on a deadline and trying to solve problems, this Web3 YouTube problem, as rapidly as possible. Is the orchestrator now is partly centralized, it's being iteratively decentralized over time. That eventually all this will be decentralized with smart contracts, and you'll be able to interact with and interoperate with all the control plane and the orchestration all via smart contract, but we're not there yet. Now, you mix all of these together and you get something explosively magical. This is, by far, unequivocally, my favorite slide of the whole deck. And let's walk through why. There might be some name brands you recognize up top. Cloudflare, maybe a few people have heard of that here. What this is time for these networks, Cloudflare, Fastly, and Saturn, to reach 25 terabits per second of capacity, of total capacity of the network. And if you look all the way over on the left side, you'll see Cloudflare. What this means, it took Cloudflare 10 years from their inception to build a network with 25 terabits per second of capacity. Next over, Cloudflare's brother, is Fastly. It took Fastly 7 years to build a network with 25 terabits per second of capacity. And last but not least, our plucky little underdog that is ascendant beyond is Saturn. It took Saturn one, pardon my French, fucking year to reach the same capacity that it took Fastly and Cloudflare 7 and 10 years respectively. This is the gasoline that Saturn is cooking with. This is what decentralization, this is what crypto incentives unlocks. And we're just getting started. This is a picture of what this growth looks like. So this is a screenshot I took of what's known as the Saturn Explorer. You can check it out at explorer.saturn.tech. It is a giant blow-up 3D globe, and you can spin it around and take a look at every Saturn node on the planet. And you can dive into every Saturn node. You can click, 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 and see the Filecoin earnings per Saturn node, the time to first byte, the amount of data they've sent. You can see it all. It's a public network. And what we're looking at here is a picture, of course, of Europe. And every little blip you see here is a small cluster of nodes. So imagine that one of those little Amazon warehouses that I've now alluded to a few times. And the number inside of that little blip, is the number of nodes in that cluster. And if we walked back a year ago, literally 1 year ago, Saturn launched 21st of November 2022, not even a year ago. This would be a completely barren wasteland of Europe. Nothing, not a peep, nothing. And now you can see we have nodes all over Europe and growing. This is what happens when you unlock decentralization and crypto incentives. Now, how can you get involved? Where's the network now and you want to jump in? One of the ways you can jump in is you can run a node. And so over here we see various tools we've written, like you can see your earnings here, your bandwidth served, the number of retrievals. We have a real-time dashboard where you can see all the nodes in the network and all their statistics. Again, it's a totally open network. And what does it mean to run a node? What it means is you have a server, you install Saturn software, which is all open source. You can go take a look at it all on GitHub, and you essentially offer your disk and you offer your bandwidth pipe to the Saturn network, and content starts being cached. You start receiving requests, and you contribute and serve requests to end users, and you earn Filecoin in return. And how is it built? How do you actually run it? It's just a Docker container. You put your Docker container in your server, and done. That's it. And the requirements to get involved are a 10 gigabit a second upload link and a 4 terabyte SSD. That's it. You can spin up a server, or if you have a server available that meets these requirements, I encourage you to run a Saturn node and put your blip on the map. Now, there's one other key piece that I'm also really excited about, and this is forthcoming, hot off the presses. Saturn will soon, in the next 2 weeks, be launching a private beta for websites. What does that mean? If you run a website that loads content address content, if any assets in your website are loaded via SID, this beta is for you. And what it means is you'll be able to, in 2 weeks, participate and join, and you'll get a little browser client that runs in your website. And what it does is it detects requests made by your website for content address content, and it shoots them to Saturn and loads them faster and cheaper from Saturn. And so this is launching in 2 weeks, and if you have any interest in participating, again, if you have a website and want to load content or content from IPFS or Filecoin, please come talk to me. I'm not hard to find, I'm loud, I'm excited, I'm always rearing to go. Come talk to me, I'd love to talk with you. And now, where's Saturn going? Now, we've talked about its past, how it's designed, how like the problem it began to solve, and where's it going? Well, 1 year ago, November 21st, 2022, in Lisbon, Portugal, we launched. And now we're coming up on the customer launch for websites that I just mentioned in 2 weeks. And next up is edge storage. So there are other people who don't just want to distribute content, but also want to store content at the edge. And Saturn nodes will, in the future, be able to store, kind of like an IPFS parlance, you'll be able to pin content on the edge somewhere. So not just cache it, but store it in a permanent manner. And then, of course, we're always and iteratively walking towards full decentralization. You know, like I mentioned before, the orchestration and control plane is partly centralized, partly decentralized. And we're waiting on a bunch of great tools to come out of the ecosystem. Like IPC will be a fundamental linchpin of a lot of Saturn's decentralization, and that's also under active development. Now, I want to point out one other thing. Why, Ansgar, are all these things plotted on an exponential curve? I want to go back to the key underpinnings of Saturn and how we've grown from 0 to hero in under a year. The fascinating aspect about Saturn, and this is why Saturn's going to win, with asymmetric warfare. When we don't control all the architecture and the infrastructure, and all of our software is open source, every time Saturn engineers all go to sleep, the network grows. People are still adding nodes, people are still adding capacity, people are still optimizing the network's getting faster, the network's growing and it's getting larger, all while we sleep. And we've seen this. If you look back at our growth, again, juxtaposed with the growth of Fastly and Cloudflare, we are out of the gate like a rocket ship because we don't need to grow like a Cloudflare and Fastly. Cloudflare and Fastly grow by getting a bunch of suits in a boardroom, getting out a checkbook and saying, where should we go build the next data center? Where should we go put a bunch of capacity? We don't do that. Saturn doesn't operate like that. It's asymmetric warfare. Anyone around the world, without my permission or anyone's permission, could go spin up a node and start contributing capacity. And that is the key difference that unlocks Saturn's growth. Now, I'd love to answer any questions you guys may have about Saturn, about its architecture, about where we started and where we're going. And to spice things up a bit, unfortunately, there aren't any Saturn candy bars available yet. So I've got the next best thing, Mars candy bars. So if you ask a question, and I would love for you to ask a question, please ask a question. There is a Mars bar with your name on it. Thanks, guys. Yeah, please.
So are there any plans to build like a managed HTTP gateway in front of this, or is the expectation I use the client and do that myself?
Great question. So we absolutely will have managed HTTP endpoints that if you want to trust us instead of kind of running your own client, where those managed gateways will do the verification and then send you the post-verified content after. So absolutely there'll be ways to interact with the Saturn network where essentially instead of verifying locally, you can verify remotely, if you will. Nice. Is that your question? Answer your question? Yeah, great question. Great question. Yeah.
So can you talk a little bit, because I know like one of the biggest challenges in an open decentralized system like this is always, particularly an incentivized one, is always like abuse and fraud, right? So can you talk a little bit about how you think about that and how you imagine being able to scale that up at the same kind of exponential growth that you're seeing on the network?
That is a great damn question. Here's how I think about it. And there are many ways to think about it, but here's how I think about it. Anytime you go to a website without ad block, you see ads. And the way that advertisement networks work is they can't stop click fraud. There's nothing they can do to stop you loading your own website and just clicking on your own ads, right? And this is an unsolved problem. Again, there's no way to stop that. However, a lot of people have spent a lot of time, especially at Google and other ad networks, building anti-fraud and click fraud mechanisms and algorithms to detect this and fend against it and control it. And so some percent of all ad clicks and all ad views online are fraudulent, right? But that has not prevented ads from being the business model that powers the entire internet. In other words, it is in a controllable and not, I'd say, death stroke level. if you will. And that's the same way that I view Saturn and the Saturn network. Insofar, there's nothing we can do to prove every retrieval was kind of not collusion or not fraud. Like, there is no proof of bandwidth retrieval. There's nothing that fundamentally we can do to stop someone spinning up a Saturn client requesting from their own server and saying like, hey, please now pay me, right? They own both parties. So what we do for now, and we'll get to where we're going in the future in a second, what we do for now is the same thing that the ad networks do, which is we write a bunch of software and we do our best to detect and prevent and punish and disincentivize this. And so far, so good. You know, and we've seen this. We've seen people like commit fraud on the network and be penalized, and it's a cat and mouse game back and forth. But we don't think it's an insurmountable problem in the same way it was not an insurmountable problem with ad networks. Now, one key piece here. Why did we kind of get in this game to begin with? We would love if clients had their own wallet and actually had to pay for retrievals. Because if an end client, he had a little wallet, and every time it fetched content from Saturn, it actually had to pay for that fetch, you get around all this kind of fraud detection. You don't have to detect that anymore because clients have to pay their way. Why didn't we build Saturn like this? We didn't build Saturn like this where clients have to pay because that's just not how the internet is built now. Like, when you go and try and access a website, you don't have to put a bunch of pennies in your browser to go load google.com and to go load other websites. Now, with Web3 and the advent and growth thereof, we hope that eventually the web might arrive at a model like this in the future, where when you go to a website, you have to pay your way. And again, it's not $100 to go to google.com, it's 1,000th of a penny. But the point is you are directly exchanging value with Google, who sends you a return of the website. And in that world, a lot of this fraud and anomaly detection goes away because clients have to pay their way. So that's the world we want to go. We want to get ourselves out of having to do this anomaly detection and fraud detection and kind of having the orchestrator and the network itself police itself, right? But we're just not quite there yet. To really nail that requires a fundamental shift in oncoming kind of Web3 where clients become actors in the network and have a wallet associated with them. So anyway, I hope I was able to answer your astute, sage question about anti-fraud and anti-fraud detection and how we think about it now, how I personally think about it now, and then where we'd like to go in the future to dodge that entirely. Does that answer your question? Yep. Great question. Great question. Any other questions? Okay, thank you so much, everybody. Thank you.
Well, welcome back. We're getting started then a few moments late, but we're starting with Guling, which will be presenting for us decentralized social network with IPFS. So, take the stage. Thank you.
Thank you, everyone. I think we have fewer people than a full room, so if you anytime you have any questions, you can just stop me, raise your hand, and we can kind of move into a more discussion mode. So today, I'm going to talk about how we're building decentralized social network with IPFS directly, how we are kind of putting a most practical way that we can think of together, and how does that look in real life with real users. So I'm the co-founder and CEO of Matters Lab. So the work I'll be talking about here are basically me and my colleagues did in the past 2 or 3 years. So we all know that social media is kind of really important. It's basically why people use internet. The user number of social media is basically the same as the user of internet users. So I think last year we have more than 4 billion social media users. And it's also, basically it's a network that controls how we think, how we reach consensus, how our collective emotion work, and it also shape many geopolitical issues we're facing right now. So it's definitely one of the most important things, or one of the most impactful innovations we have come up with. So when people talk about the issue of social media, there are many issues of that. You have fake news, you have centralized control, you have censorship, you have propaganda, lots of different things, polarizations, etc. When many people have different opinion on the problem, but many people have the similar solution, is that we need to decentralize social media, because social media cannot be controlled by any single entity. It should be something that's a basic right for human. We have the right to talk to another person, we have the right to express our opinion. So fundamentally, social media should be something that's regarded as a public good. It should be something public, and so it should be decentralized without any specific control. And the vision, I think many people, many teams have tried to depict is that it's a network that spans across different applications. People can keep their connections, keep their identities, while they can hop between different applications. So it more or less looks something like this. It's like a public highway. You can go from a point to another. The different stations, the different applications, are different access point, but you do have your data with you, you have your identity with you, and you have your basic rights with you. There's a lot of advantage of this kind of vision, this kind of decentralized social media. Some of them are ideology, like people just own their data and have the right to say anything they want at least at a basic level. But there's also a lot of economic or evolutionary advantage of that, because once you separate the data layer and the application layer, you get a faster iteration of applications, because you kind of break the network effect. There's no one company that control the network. So any application can hop in and make a better UI, UX, makes a better index or recommendation system, so you have fast iterations. You also have a diverse array of discovery and recommendation mechanisms. You can have marketplace for those, so that you don't have the same echo chamber everywhere. So it's not, instead of Twitter's recommendation algorithm controlling how people think, how information is spread, you can have a vastly different way of mechanic designs to kind of determine the value in the network. And it also becomes a better option for the user, because then the user have more options for the application, more options for the recommendation algorithm. And if we have the data controlled and owned by the user, we also have tons of benefit from that. We have portable identity. The user can basically become stickier with their identity. They don't have to change the identity when they hop from different platforms. It also becomes censorship resilient, which in a lot of countries in the world is still a huge problem that we have not been able to solve. So the list goes on and on. So it's definitely something a lot of teams are trying to work on, trying to solve. And I personally think it's the biggest potential impact that any decentralized technology or decentralized network can make, because that's the single thing that everyone uses. If you think about DeFi, there's only like 1% of people in the world who actually actively do finance, but everyone uses social media. Everyone talks to another, to their friends, to their families. So if we think about real-world impact, it's definitely social media. Even if we don't call it social media in the future, some form of social connection, online social connection, has the biggest impact. That's basically shaped collectively who we are. So a lot of teams have been working on this problem, try to come up with new protocols to define how the social graph comes together, how people can talk to each other online, how they define the relationship, and how you financialize those relationships to make the users gain value, gain profit from that process. I'm just listing a few of the projects that have been gaining tractions or attentions in the past. But from our perspective, because at Matters Lab, we're trying to build applications. We're trying to build applications for real users. It's very interesting that from an application perspective, we actually have everything we need already. All the basic components for that vision I just described, for a decentralized social network where you can bring your identity and data with you, and you can transfer among different applications. All the core components we already have. It's basically the internet itself, in a way. Internet was built that way. Internet, the original vision of internet was that it's a cross-application network that the same data, same content can be rendered in different clients. So basically for multimedia content that is cross-application, we have HTML, CSS, and JavaScript. That's basically web app. We just write that every day as developers. For subscription feed, we have RSS, which is not hugely used in a lot of contexts, but for example, podcasters or musicians, that's still their everyday bread and butter. They still use RSS to kind of distribute all the information, whether it's Spotify or iTunes. And for social graph and activity, we also have ActivityPub, which is a W3C standard for how you define your social graph and activities in your social circles. It's also the application, the protocol that drives Mastodon and many other applications. It's also one of the standard that Threads from Meta, when they launched, that they promised to tap in as well. So, but the problem with them is that those standards they started at a time when we have a different understanding about decentralization. We are very much in the world of server-client relationship. When the internet started, in a lot of ways, those are specifications for servers. That's how servers spit up the data and how client can understand that. So the interesting thing about IPFS is that, so when IPFS started in 2016, the most exciting thing to me is that I feel IPFS is this thing that can stitch all these different standards together. Because IPFS has a very sweet spot between content addressing paradigm and also being backward compatible with a lot of servers. So I'll basically show you how in Matters Lab we're using IPFS to stitch together all the existing standards to kind of form a most practical ecosystem for the users. So I'll also talk a little bit about Matters Lab, so just to give you a context of what we're working on and why we need this kind of protocol, why we need a very extremely practical way of thinking about this problem. So one of our biggest applications is called Matters Town. 85% of the users are Chinese-speaking users, which is probably one of the language group that has biggest issue with censorship, which also makes decentralization a huge opportunity in a sense. The rest 15% include like Russian users, Arabic users, also English users, but mostly for the people who are facing serious issues in their current centralized social media. So we have many, for example, journalists or activists publishing longer form of content on Matters Town. So in terms of size, we have more than 100,000 authors, more than 100,000 wallets, and at our peak time, we have more than 6 million monthly readers. So that's kind of the scale we're operating on. And the problem we have seen in many new protocols, social protocols, is that they're still not very good at handling the scale we're operating on. But IPFS is very good in that sense because it's quite mature technology. We have experimented quite a bunch with BitTorrent, and if we combine IPFS with all the existing standards, it's actually a very, very solid starting point for us. So I want to show kind of like a short demo to kind of show you what it looks like. Let me just open my Brave browser. So what you can see here, this is my my personal profile on Matterstown. This just looks like a normal web app. We have a bunch of different type of content, image, articles. You can go to any other articles, and they're just normal articles. They have videos, image, text, everything you can imagine, just like a normal website. But under the hood, it's actually quite different. So if you click on the subscribe number, you can see there's an ENS here. That's my ENS domain. And if we go to the terminal, and so let's try to resolve that. If I try to resolve the ENS, we'll actually get an IPFS hash. And I will actually already get it locally, so just for it to be faster. So if we try to get this package, and let's try open it up. So it's actually just a directory stored on IPNS. You have a lot of subdirectory representing each of the articles. Under that directory, we have quite a bit of the kind of the standard internet way of doing social. For example, we have WebFinger, which is one of the most widely supported standard for identifying identity in a decentralized way. We have about.json LD. If you're familiar with ActivityPub, this is the way you specify a person on ActivityPub. We have index.html, so it's a standard web app that renders out my personal profile. And we have Outbox, which is also part of ActivityPub, and we have RSS XML. So those are all very mature, standard way of describing a person, and we basically dump that onto IPNS and attach the IPNS to ENS domain. What you're seeing in this application is rendered from that data. So we basically render out that data and add a bunch of better styling, basically, for that data. But what's the advantage of that instead of just storing in a database? We have all the advantage we just described right at our fingertips because all the applications are ready. So, for example, I can go to any of those ENS gateways. This is the use.limo, one of the fastest gateways. And I can just render all my content there. It's a standalone static website. Even all the image, you can see that it's stored inside that directory. So everything is packaged together and transported directly through that limo gateway. Because I'm in Brave now, Brave has a internal local IPFS node. I just typed in my ENS name, so it gets resolved into the IPNS hash under the hood directly. So this content I'm viewing now is entirely local. It's peer-to-peer transported into my browser. And for example, we have another application called Planet. It's a peer-to-peer reader based on IPFS. I can also just type in my ENS domain and have all the content here right under my fingertip at my desktop. So this is extremely helpful if you're living in, for example, in China, or you're living in Iran or in Russia, in a lot of places that certain block site gets blocked, and you can still transfer the data in a peer-to-peer way purely on your local devices. So that's super powerful. I think that's one of the most practical use cases for decentralization, although we talk about decentralization mostly as a human rights issue, data rights, or as an ideology. In, for example, United States or West Europe, it's very hard to find an actual use case for that people just absolutely have to use it. But decentralization in a peer-to-peer sense, it's peer-to-peer so that no one can cut off the connection or the network, is actually hugely valuable in many parts of the world. So we're basically tapping into that market, tapping into how that's useful and valuable in real life. And so this is only referring to storing web app on IPFS. But if we start adding ActivityPub, the social part, it's become even more interesting. So if we go to Mastodon.social. The interesting thing is that this, if you don't know about Mastodon, this is probably one of the biggest social applications outside of Twitter. When people don't really like Twitter, they just basically go to Mastodon. And it's distributed in a federated way, so different servers talk to each other using this standard called ActivityPub. So let's try here, and if I type in my ENS, but with a gateway domain at the end, I can actually view my own profile in Mastodon. So everything is stored on IPFS just as I showed here. Everything's static, stored as a file here. But just because we're using the standard way of telling each other who this person is with WebFinger or the information about this person with ActivityPub, we can actually use a lot of different clients, including Mastodon, one of the biggest, most popular clients, and many other applications to tap into this social network. For the Mastodon users or for ActivityPub users, this is actually turning ActivityPub from a federated protocol into a peer-to-peer protocol, which is actually quite significant because for ActivityPub, the biggest problem of that is not peer-to-peer enough. It has to be tied to server, but with IPNS, we can actually all make that happen. We can turn it into a specification that can be peer-to-peer. So just kind of to wrap up, what we did there is that we're just treating web app as a universal content format. You can store anything with HTML, JavaScript, and CSS, video, image. It's just very mature. It's how the internet works. And we're also treating ActivityPub as a social protocol, but with a twist, because we combine ActivityPub with IPFS and IPNS. We're turning ActivityPub into a peer-to-peer social protocol, kind of just abstracting it away from the server side. And we're using IPFS as a content addressing scheme, and also the IPNS, also Ethereum key pair becomes the identity, because what's controlling their whole content is the key pair used in IPNS or the key pair used in Ethereum key that controls the ENS domain. So if we visualize that, kind of looks like this. The whole way of resolving this content is that we start from ENS, that's a human readable name, that gets resolved into IPNS, and then that gets resolved in the web app that's rendered in the browser or any other client. The RSS feed, which can be recognized by any, for example, Spotify or iTunes podcasters would use that in the application. It can also be resolved into ActivityPub, so other clients can read that, and then it can further resolve down into any number of subdirectories that has all the same standard, web app, RSS feed, etc., in those articles. And each piece of those can be fully dynamic, because each piece of those can be a web app that's fully functioning, fully interactive. So I think to us, the quite interesting question that I kind of also want to present to the few of us who are here is this interesting problem. We already have the component for decentralized social media ecosystem, right? We basically have proved that it works, and it's extremely scalable. We scale that to millions of users. So what's next? Like for that decentralized social media vision, that vision almost started in the beginning of the internet, right? We would constantly talk about it a lot. What should we do next to bring that into reality, for more people to be on this social network that's not controlling them, but something that they can control? I'm basically just listing here some of the dilemmas we have seen while we are on this journey. I think it's extremely hard to design an application that fulfills user need. So it doesn't make sense to clone a Twitter in a decentralized way. We have to find a different thing. We have to do something different that's vastly better than Twitter or any social applications for it to work. It's not better in a technology sense. It's better in a user experience sense, also in a human nature sense, so that we allow a better part of humanity basically to surface from that application, better content to come out of it, better consensus to come out of it, and less polarization, less hatred or anxiety driven in the platform. But it's very hard to do that. How do we do that in a way that still sticky in an economic sense, that people can still want to use that application and someone is still paying for the resources being used to run that. And it's also harder to get sustainable user growth and value production. How do you design a system that can keep growing at least up to a certain point and still producing value in the real world, pumping out good discussions, good consensus, good ideas that is positive in this society. But on the other hand, the reason we're seeing a lot of new protocols coming up, while we know that we already have the standard or components we need, is that it's way easier to raise funds for a new protocol or infrastructure. Even though from an application builder perspective, we have everything we need, it is a better story to tell if you're building a new protocol and new infrastructure. And it's more convincing to say that, hey, I can capture more value in that protocol. I think that's a story, that's a problem that if you're founder, if you try to start a company, you have all faced. I think that's the problem kind of goes deeper into how the funding structure works currently in startup world or more specifically in Web3 ecosystems. It's a problem I think very hard to solve. Also a problem I would love to hear any of your opinions on. But that's a problem we have to face if we're trying to scale this ecosystem into real people's hands and life. So I kind of just want to leave you with kind of the lessons we learned in those journey for the past 5 years, is that this structure is kind of still the most practical way to do a decentralized social application or a decentralized social network. You also have a huge network effect in that because ActivityPub already have more than 10 million users. That's way bigger than the user size we're seeing in Web3 or any of the protocols in Web3. That's probably the most practical way of building an application. And because of the widely supported standards, such as WebFinger or just web application HTML itself, we already have a universal content format. All the browsers are basically clients for that, and we can tap into that system instantly. IPFS is pretty much mature as a content addressing scheme. We can just use that the speed is sometimes not perfect, but we can make it work, basically. And IPNS in Ethereum is also getting mature as a user-facing identity management system. So from a builder's point of view, I can kind of summarize that as a lesson we learned. Although there are still problems, for example, the funding structure that I have mentioned, but this is kind of the lesson we want to share from our past 5 years of experience. So if you're interested in the work we do, interested to know more about what we're building, why are we building this way, or any form of collaboration, you can find me in that email address, or you can visit matterslab.io to see the work we're doing, or for more updated information, you can go on Twitter. There's both a Chinese version and an English version of that. Yeah. Thank you. Let me know if you have any questions.
Okay, thank you. For our next section, we have Vesevolod Breus. Sorry, I totally mispronounced your name. He's going to be talking about DBox, enabling greater decentralized storage acceptance among Web 2 users.
Hello. Let me see how this works. Where do I press it? Oh, that's okay. Great. Hi, I'm Sevalad. Today I'll be sharing our project that is based on IPFS called DBox. Essentially, as the name suggests, we're adding another decentralized Dropbox to the ecosystem with our own spin on it. So we'll look at how DBox is working towards enabling greater decentralized storage acceptance among Web 2 users, and also how DBox specifically uses IPFS to do that. So to start, a few words on the state of decentralized storage today, comparing the traditional cloud storage market with its decentralized counterpart. I came up with various estimates, but they all more or less fall into a juxtaposition of zettabytes versus exabytes, so a difference of 2 to 3 orders of magnitude. Now, even though the decentralized storage is an emerging market, I want to highlight a few more points that account for this size disparity. As we all know, decentralized storage is fairly non-trivial, so right off the bat, the complexity scares away many potential users. I mean, have you ever tried to explain IPFS or Filecoin to a friend? Right? We've all done that. Decentralized storage also requires a certain minimum amount of IT knowledge, which most average internet users typically don't have. And finally, much of Web 2 is built around certain workflows that underpin the functioning of modern society. And as a result, the Web 2 usage paradigm, including the interfaces, applications, programs, has been really ingrained in user habits. And it seems that in many cases, trying to offer an alternative, Web 3 applications, including decentralized storage, don't completely align with these common usage patterns. So let's talk about the good things about cloud storage. What are some features of cloud storage that make it universally accessible to most users? Native integration with the user's operating system. So essentially, all cloud storage solutions just work out of the box. In addition to a simple, easy-to-use web interface, many provide a desktop sync client that is integrated with the user's file explorer, enabling users to sync their data via local file system folder. Easy data sharing. Cloud storage not only enables you to easily manage your own files, but also manage the files that you would like to share with others, and those files that have been shared with you. And this is usually done through simple access control. Usually all users have an account with the cloud storage provider. A user can add other users to the access control list associated with a particular folder or file. And due to the centralized nature of cloud storage, a user can easily share data with another user that will be online after the first user has gone offline. And finally, fast and convenient data saving and retrieval. Cloud providers rely on high bandwidth infrastructure that enables supporting a vast user base. Generally, most users have a good and fast experience saving and retrieving data. And also, generally speaking, data retrieval happens at no additional cost to the average user. So let's talk about DBox. As mentioned already, in order to enable a greater acceptance of decentralized storage among Web 2 users, to participate in bridging that gap, in other words, DBox aims to bring the good things about cloud storage that we just saw to the decentralized storage space. When designing DBox, we wanted to leverage existing IPFS core features while also adding functionality on top to achieve the following. First and foremost, DBox is designed with maximum user privacy as a primary feature. We don't use any auxiliary centralized infrastructure. DBox is completely based on the infrastructure of IPFS. We don't have any user registration or accounts to avoid tracking user usage. We offer no centralized API services, such as IPFS pinning. And finally, DBox is functionally independent from us, since we wanted to design a truly decentralized system. So going back to the good things about cloud storage, we'll look at these features and see how Dbox is in the process of implementing them. Starting with a deeper look at the native integration with the user's operating system. So folders, they're everywhere. The folder usage paradigm lies at the core of the native integration of cloud storage with the user's operating system. Users primarily work with folders. When computers first appeared, we had local folders. When networks started to appear, we had the advent of network folders. And the next step in this evolution were cloud storage folders. They acted as regular folders, but were directly synced with cloud storage providers. So as we see, folders aren't going anywhere, at least not anytime soon. Within the folder usage paradigm, all operating systems have built-in features that all users employ, such as search, access control, access to individual file or folder properties and metadata, as well as additional functionality via context menu. And another thing to note, applications generally primarily interface with the local file system, so essentially building on top of this folder usage paradigm. So even though we have web interfaces and SaaS platforms, the folder usage paradigm still lies at the core of computer usage today. So who remembers WebDAV? Supposedly it was a thing a while back. For those that don't know what WebDAV is a protocol that enables users to perform standard file operations such as creating, deleting, moving, and copying files and directories on a web server. So what does this have to do with folders and integration with the user's OS? Well, a while back, we were looking at the prospect of using the folder usage paradigm to interface with IPFS. After some research and trying out various approaches, we quickly realized that we could achieve this using WebDAV. Since if we ran WebDAV as a local server, we could create an interface between IPFS and the operating system by obtaining direct access to IPFS's mutable file system, the MFS, as a mounted network drive. So this greatly improves accessibility to the data in IPFS. You can now directly interact with the files as if they were part of your local file system via your file explorer. Serving the files in such a way enables you to add any sort of arbitrary stream, file stream processing functionality, such as file encryption and subsequent decryption. So you can have an encrypted file in the IPFS MFS. The same file, but decrypted, is then accessible via the file explorer. Any file manipulations would then be re-encrypted and reflected back in the IPFS MFS. Also, the fact that WebDAV is supported by all operating systems made this approach look promising. Again, native integration with the user operating system across the board, Windows, Mac, Linux, etc. So about a year ago, we created IPFS WebDAV. It's a module that does exactly the aforementioned. For those that are interested, it is available on our GitHub. The IPFS WebDAV proof of concept served as the initial inspiration for Dbox. For those familiar with WebDAV, our implementation passes the official WebDAV server protocol compliance test suite called Litmus with 100% test coverage, demonstrating full compatibility when interfacing with IPFS. So at the core of Dbox, we have the Dbox FS. The Dbox FS is similar to IPFS's MFS. In fact, we originally used IPFS's MFS but lacked certain metadata functionality, so we built our own Dbox FS. It enables the user to work with the hierarchical tree structure of the files that are in dbox, and like with MFS, the actual files are stored in IPFS. So why not just use MFS? Well, we needed additional metadata support for implementing dbox-specific features, but we also wanted more data privacy than MFS provides. Using MFS, you can still see the size of files in IPFS, as well as the hierarchical tree structure of those files. We wanted to obscure this information to further enhance user privacy. So finally, as a step towards native integration with the user's OS, dbox uses WebDAV to enable access to the dbox.fs as a mounted drive, essentially bringing the convenience of the folder usage paradigm when working with files that are stored in IPFS. Well, not stored, but accessible. So currently in dbox, dbox.fs can already be accessed as a mountain drive, as I just mentioned, in the user's file explorer. We are also currently working on integrating dbox functionality into the file explorer context menu, which will look something like that. This would enable users, for example, to add files to dbox directly from their file explorer, to share files with others via dbox, to view dbox metadata for individual files. And we're also working on a desktop application, which would give the user easy access to all of dbox's additional functionality, such as searching, access control, file metadata, and sync state. So the next good thing about cloud storage that we'll look at, and that dbox implements, easy data sharing. To understand how dbox implements this feature, we'll look at how data sharing fundamentally works in dbox. Data sharing here refers to sharing data between individual dbox nodes, whether between users or between devices belonging to a single user. So let's go through a simple example. We have 3 nodes. User 1 wants to share a local folder with users 2 and 3. User 1 first needs to add the folder to his dbox.fs. And remember that a folder file that is added to dbox.fs is automatically added to IPFS, since dbox.fs is an abstraction. Next, to share a folder file that has been added to the dbox.fs, we use an abstraction, a dbox share, to internally denote that the folder file can be shared over the dbox network. Each dbox share has a state that defines the owner, share members, access level of members, such as read-write privileges, and the content IDs of the shared contents, and other metadata. Since the data itself is in IPFS, user 1 needs to somehow provide the content IDs of the share contents to users 2 and 3. Users 2 and 3 would then be able to retrieve the folder contents from IPFS using the provided content IDs. So how does user 1 provide the content IDs to users 2 and 3? Well, user 1 has a running process that users 2 and 3 can connect to and obtain the content IDs of the files in the share. We call this running process the dbox keeper. The dbox keeper manages the share state and enables exchange of metadata among share members, controls access to the share. User 1 provides access to users 2 and 3 by adding them to the share as members. And each keeper has an identifier, which dbox stores in IPNS. This identifier is used by share members to connect to the keeper in order to retrieve the share metadata, granted that they have the appropriate access. So using the retrieved share metadata, which includes the content IDs users 2 and 3, can then retrieve the corresponding share contents via IPFS. So while all these aforementioned abstractions provide access control for folder file sharing, IPFS does the actual heavy lifting and content routing under the hood. However, as you all probably know, IPFS does not provide any out-of-the-box encryption. So if anyone has the content ID of your file, they will be able to retrieve it and view its contents. And we needed a way to ensure that only share members would be able to share, to view the share contents. So we have to encrypt the data before it is added to IPFS and distribute the decryption keys to the intended recipients, the share members. And after evaluating various potential solutions for this problem, we realized that certain key abstractions used in Signals protocol mirrored those in the data sharing flow used in dbox. So we decided to use it. The dbox keeper provides similar functionality to Signal server. Dbox client corresponds to a Signal client app. Dbox share similar to a Signal group. Dbox share member corresponds to a Signal group member. And finally, an event in dbox referring to changes in the share state, in the dbox share state. It behaves like a Signal message. And Signal is also trusted by big names such as WhatsApp, Facebook, Messenger, Skype, proven to be reliable by extensive third-party auditing, and the code is well-maintained and accessible for developers. So using our dbox protocol, which is based on Signals protocol, we achieve the ability to securely distribute the decryption keys and necessary metadata to share members, enabling them to maintain secure access to the share state. This was an overview of how dbox implements data sharing. It might sound a bit convoluted, but most of this happens under the hood. The user is abstracted away from any complexity and merely needs to sync their files. So the final thing that we'll look at, fast and convenient data saving and retrieval. Users ultimately use cloud storage for saving data that exceeds their local storage capacity. And accommodating this functionality in dbox requires integrating with the IPFS Filecoin data persistence and retrieval ecosystem. The main ways for persisting data in the IPFS ecosystem are using an IPFS pinning service or some sort of equivalent, or Filecoin, with other projects such as Saturn and Titan that provide supporting retrieval functionality. Dbox ultimately requires low-cost, decentralized, low-latency retrieval, mainly for relatively small amounts of data, megabyte, gigabyte, low terabyte range. So at this point, we have not yet been able to implement such retrieval using the current version of various IPFS ecosystem members. With IPFS pinning services, you're restricted with your reliance on a third-party service. With Filecoin, the saving and retrieval process is complex with high latency retrieval. Even though we have seen much progress and are anticipating much needed improvements. And with something like Saturn, well, a CDN just isn't the best paradigm for private user data. So, in short, we do not have a solution for this at the moment. However, we are currently looking into things like IPC and FVM, and other supporting platforms such as Spark and dstore that could potentially be instrumental in enabling us to implement this saving and retrieval functionality for the dbox network. So to sum up, dbox is on track with implementing native integration with the user's OS, offering easy data sharing, while we are actively working towards bringing data persistence and retrieval so that users would be able to store as much data as they need. For those that are interested to try out dbox, you can find us online, dbox.network. Here's a QR code for the link. We just launched the website, so we're still in the middle of writing the documentation. But we do have a quick start using the dbox CLI interface. This is meant for users to get a feel for how dbox works. The CLI functionality will eventually be encapsulated in a much more friendly desktop application, as I mentioned. Nevertheless, it's there for you to check it out. Regarding our tentative roadmap, Q1 of next year, we will be releasing our first stable version, along with the core code base being open sourced on GitHub. In Q2, we are planning to release the full desktop version of the application. And by Q3, we plan to have a proof of concept for saving and retrieval. In Dbox, we will be writing articles detailing our developments and posting them on our website and on Medium. You can also find us on X. So if you have any questions, please reach out to us. Otherwise, stay tuned for the latest news. Thank you.
Okay, thank you. So next up, we have privacy-focused user access for consumer dApps with Vijay Krishnavanshi. Thank you.
Okay, I think we can start. Hey everyone, hope you are having a good session. So let's get started. Okay, so today what are we going to look at is how can we move some of the most important activities that we are doing on the internet off of the centralized infrastructure that we are already using, right? And adopt a new type of apps, which are called trustless apps. But before we look into it and I explain you how to do that, I need to show you the current infrastructure and explain about some issues that we have with it. So, internet today looks something like this, which is usually there is a front end which talks to a backend server, which controls what type of actions a particular user can or cannot do on that website, on that service, and things like that. So, like if you have any account that you have created on any website, you have username and email and all of these things. So it's a normal flow where you authenticate to a backend server and then come back and then do some operations on top of it. With the architecture that I just showed, this it has served us very well in the for the past few years, right? And we were able to do things like, for example, with good UX, good low latency, and these kind of things. But it came with two key problems. What are those problems? Single centralized point of failures. So with the architecture that I showed you before, we have centralized single point of failures, and whatever is happening on those servers doesn't come with any form of computational integrity and data integrity with it. And it's sort of a trust-based system if you are using those services. What you're doing there is putting that trust in those companies and saying that they are not going to do anything malicious either with your data or with whatever form of things that you have stored there. And there are a few problems that come with it, which is they cannot delegate access to other people to use those services on their behalf, or these servers becoming high-value target for hackers, because a lot of these, all the identity of all the users that are there on these services are controlled by those servers. Now, I showed you the architecture, now the key problems. How do we do better? So the question is, can we do better? And the answer is yes. So what we can do in this, in the new architecture that I'm going to explain, which is replace our backend with smart contracts and P2P networks. And instead of relying on a server for doing any form of authentication, we can use UCANs and we can do we can do the JWT generation on the client side, right? And instead of credentials like username and passwords, we can use things like MetaMask or like wallets and ERC4337 wallets or multisigs. To help you visualize what would that look like in any app that you're thinking of building or if you're thinking of adopting a trustless setup. So there is a web client which is pinnable on IPFS, meaning it's, think of it as a static piece of code that's there and will not change. Then you have this web client responsible for generating access tokens and also like managing the keys for the end user, which does one-time setup with the smart contract. And then you also have the peer-to-peer backend, which is sort of doing all the verification related to those credentials and talking to the smart contract for pulling those keys and doing that verification, right? And then after, like in this setup, what will happen is like web client will then be able to directly talk to the peer-to-peer backend and do all the operation that it needs for in that app. Now, I showed you the architecture, but what are the benefits? Like, why would you even think of adopting something like that? In this, the access can be granted on to any level of granularity that you want, right? What you could do is you could assign a limited set of permissions to one user, or you could assign, let's say, pseudo access to full users or these kind of things. There is no auth bottleneck, so if you have built any form of microservices type of architecture, you know that auth is the bottleneck there, and this type of architecture removes that. And it can work with any form of signature schemes. So the architecture that I explained about using smart contracts and relying on them for storing the keys, you could put any type of keys there and you can then use that in your stack and for any form of verification like that. They can delegate subset of permissions, they can generate their keys, put it into smart contracts, they can do it on the behalf of the safes and the ERC4337 wallets that they might be using. And with the architecture that I showed, where the backend is peer-to-peer, they get right to exit as well, which is they don't need to rely on one provider or one person for providing that kind of service. Now, what does that look like in production? Meaning we at Fileverse are using it. So we have a web client which generates UCANs for the users and has end-to-end encryption keys on the client side, which does one-time setup to the smart contract, putting those keys, public part of those keys onto a smart contract, and then our web client can directly talk to our backend infrastructure, which is open source and anyone can host, to do the operations like storing files, creating a Google Doc type document, creating a shared whiteboard, and all of these things without relying on one server for managing all of that. Now, I showed you the architecture, right? But does it come with trade-offs? Yes, it does. Meaning the web client needs to manage the keys, and how do you make sure that that web client is able to do that? So that's why I put a what's next slide. So there are a few things that needs to be solved, which is how can you get this architecture to work with ERC4337 wallets? These are the things that we're looking at. And how can you get trustless recovery of credentials? Meaning whenever you generate these keys, how do you get the access back of these keys? You can use different recovery mechanisms that are already out there, but you could also come up with recovery mechanisms that are catering to different risk profiles of different apps. So to give you an example of that, there are 2-3 different recovery mechanisms that are interesting, and one of those we have, I and Andreas, we are working with the EF team to implement as well. It's called recovery pulse. So you can implement that with the certain risk threshold, and then you can get your credentials back of those keys. And once you have this kind of architecture, what the design space that it opens up is huge, which is you can come up with different coordination protocols that are not possible if you have a single point of authority that is allowing you to do whatever you can do. So think of it like this, that you can do a spec of a service, and that service follows the UCAN protocol and gives access to certain capabilities to some people and certain capabilities to others, right? So all of that will be possible if you follow this type of architecture. Then we also need to come up with different incentive structures so that other apps can also adopt the architecture like this and do different like interaction patterns on top of it. So few things that you get with Fileverse right out of the box, just because of the stack that we have, which is write to exit, meaning you can move whatever service that you're using, which is hosted by Fileverse, and host it yourself, and say that instead of using Fileverse's service, you want to use something that you're hosting, right? You get modularity, meaning the way that we have built a web client, it's composable or it's modular. You can pick and choose different services that you want to enable or use or not use. You get cryptographic guarantees for access permissions, because all the access permission related things are done on the client side and are done using UCANs. So you get cryptographic guarantees that they are correct. And you also get data storage and availability guarantees from Fileverse. You're able to protect your anonymity and pseudo-anonymity as well by, like, for example, being able to delegate the UCANs or permissions to someone else to use that service on your behalf. You also get composability because we are using smart contracts, meaning you can start using the Fileverse's stack with another smart contract that you just wrote, and you can mix and match different types of interaction patterns. Maybe you want to manage the access permissions using HATS protocol. Maybe you want to manage access permissions with something else that you just came up with, and so on. So all of that is possible because of the architecture. Now, I said write to exit, I think, multiple times. So why is this very important thing to have? So today, imagine this, like you're using Google for what, 5 to 10 years now, you have your entire history that's there, but can you take that data and move to another service? The answer is no. What you'll need to do is like export all of those files, then put all of those files onto another service. But what about the history or the comments that you did on a particular document that you created with someone? You're going to lose all of that, all of those, like that is part of your data as well, right? But if you follow or adopt the stack, the trustless stack that I was explaining, you get to create multiple services that can transfer data amongst themselves without having any form of centralized permissioning or any sort of issues. And the data is self-certifying with the content hash. So if, like for Fileverse, what we do is like we use IPFS for storage. So these services can transfer data amongst themselves in the self-certifiable way, and you cannot tamper with that data while doing that transfer. You get cryptographic guarantees to access permission. That's thanks to UCANs. So what you can do is like you can do authority delegation. You can do transfer of permission from one peer-to-peer network to another peer-to-peer network that wants to pull that data which you created on one network to that another network that you have. And I think the biggest thing that we are going to get out of this is like giving these kind of like interaction patterns to all the wallets that are out there. Meaning you have account abstracted wallets. How do you make all of those things work with an access permission that is that can be given or distributed like the UCAN's capabilities? So I think I'm done with the slides very quickly. So, do we have time for questions? I think we can take one. No questions? Okay.
Is it okay? Start now. Is it okay? Okay, thank you. Hello everyone, I'm Qibing from Dataless OS, and our team is Ownership Lab, which is funded by the Proto Lab and HK Capital. Today I will share the topic about the data computer, which is a fully new Web3 personal computer, which is fully controlled by a wallet. So you can use your data computer to control all of your internet data in one place. Our vision is to transform today's centralized internet as a user-centric Web3 autonomous world. Now we are facing the problem of centralized internet, which means if you log into your Twitter, your data is stored centrally in Twitter's centralized servers. You cannot understand how your data is stored and how your encryption key is managed by the Twitter. And if you cannot see your data, you cannot control your privacy, and you cannot control your data value. So in the Web3 philosophy, how can we store all of our data directly on the decentralized storage network? And how can we use the decentralized key management system to store the encryption key for our data? Is there any solution to combine all of new Web3 data layer to power Web3 sovereign individuals? So this is our design philosophy behind the Dataless OS. Now, the first thing is to introduce our Dataless product. Then I will introduce the protocol behind the Dataless OS. Finally, I will show a quick demo about how we can create a Web3 social network over the data computer. You can see in the figure, if you download a data wallet, the Dataless operation system is running inside the data wallet. So your browser will become a personal computer. And if you generate your data over the internet, the data will be stored to the decentralized storage directly through the Dataless OS. So there are no any backend required in our system. So the Dataless wallet is totally different to the traditional asset wallet. It helps everyone to control their data file over different applications. So you can use the data wallet to log into different applications over the data computer. Once you generate your data, the data will become a file and stored in your personal file system. The personal file system is created remote in the decentralized network. After you control all of your internet data, the last step is how we can monetize and control our data value. So let me introduce more detail about the Dataless wallet. Data wallet serves as a file key manager. So if you generate a data over the decentralized Twitter, the Dataless OS will generate a file key for this data. Then the data will be encrypted and stored in the decentralized storage network, and the file key itself will be stored to the key management system like LIT protocol. So whenever you generate a data over the internet, your data stream will be connected with a file stream and be encrypted by the file key generated by your wallet. So it is a fully new data paradigm to allow everyone to control their data. So now let me introduce some standard in the Ethereum and the Filecoin and in the Ceramic ecosystem. it is a theory about the object capability, which is proposed nearly in 30 years ago. So just like the AI, deep learning is proposed by many big giants many years ago. But currently, the GPT is changing everything. So, but it takes nearly 40 years. So for the decentralized system, object capability is very important in this aspect. So ceramic network is built using the object capability. So if we are generating a data stream, then we will attach our signature to this data stream. Then the ceramic network will verify if this data stream is created by your digital wallet. And the lead protocol is also built based on your signature. If you're creating an encryption key, you can type your encryption key with your signature. So now some of ecosystem friends are writing the Ethereum improvement proposal, like the EIP 4361 and the EIP 5573. So like the signing with Ethereum and the signing with Ethereum capability. So the philosophy behind this figure is, if we cannot control our key for our data, we do not own our data actually. So if we want to control our data, we need to control the encryption key for our data. So the last product I want to introduce is the hypercloud inside the data computer. The first rule for our data is a personal drive, similar to the Google Cloud and the Dropbox. But it introduced more developer programmability. So it is not a single cloud, but a set of application cloud. For example, if you are building a web Twitter, you need to set up your own application cloud at first. Then your user will store their file into your application cloud. If now I'm creating a web Facebook, I need to create another application cloud which is isolated from your Twitter's cloud. And so this mechanism helps developers to control their business privacy. For example, we are Web3 developers, so we want to allow users to control their data. But as a team or as a company, we need to ensure our business privacy. And we need to ensure our system is compatible with the GDPR. So we can return the data ownership to the user, but we need to ensure our system is isolated from each other. So, and you can look in the future, we divide the system as the internal and the external state. If users are generating an external stream, like publish a post, then the data OS will generate an internal file, and the internal file and external file will be connected together. So any of your online footprint data will be stored as a file in your personal file system, but another developer cannot access your application data. This is very important to ensure the cross-application data security. The last product I want to say is the DApp store, but it's totally a decentralized version because all of your data stored in the data computer is now stored in a decentralized system, not stored in a centralized server. Like even in Apple, Apple server control your encryption key, so they can access your private data if they want. So currently, in our DApp store, there are some projects are building social network and content platform. We believe in the future, a developer can also create an AI marketplace. So a large language model can access user data with user guarantee and user permission. Data OS is a system to maximize the user sovereignty. we believe in the future, data OS can also serve as a foundation of the network state and even DAO system. Because the DAO system is to maximize the coordination and the collaboration. The first thing is to allow everyone control individual sovereignty. Yeah. Now, the last step, I will introduce the data architecture. You can see our user flow. The middle one is the data's wallet, where the data OS is running inside the wallet. So the data wallet have both asset and data capability. You can use the data's wallet as a single asset wallet, but this wallet has more powerful function to allow developers to access the storage network, like the ceramic network, like the Filecoin, and like the lead protocol. Once you install this extension in your browser will be transforming as a sovereign computer. And the developer can create an application using our data's SDK. Once user uses the wallet to interact with your application, their publication data and the behavior data. For example, you publish a post, and I comment your post, and I follow your profile. All of these are our online data. Will be stored in your deployed application cloud. So the right side is how data OS interacting with the decentralized network. If now you are interacting with the internet, generating a data, then the data OS will generate a file key, and encrypt your data stream, and then store to the data layer, like the data key management system. And the encryption data will be stored in the ceramic database. And in the future, we will integrate Filecoin and RViv system, so your data stream will be stored permanently in the Filecoin network. So the data cloud will eventually become a fully user-centric, where you control your private key, your private data, and your data will be stored permanently in decentralized network. So our digital life will become, will all be stored in our personal cloud. In the future, we are also building middleware to connect the decentralized storage and the smart contract, so we can monetize our data and control our data value. And the more developers can create more data composability product over our core system. So here is the architecture of the data OS. It looks similar to the traditional operation system, like the Linux operation system. It is a multi-layered system. The core system is the data kernel, which integrates many functions, like the database, like the access control list, and like the identity system, and has a file system built inside. And it will expose system code to developers so they can create application very easily. The user interface is the data wallet and the data computer. So I want to introduce the developer programmability. The first step for developer is to create their own database to store their own business model. For example, if you are creating a web Twitter, the database should be the post database. If you publish something, then their content will be stored in the post database. But the data OS will do additional important thing for your application. If you are now creating your database, a file system database will be created automatically together and linked together with your own business logic. So if users are now interacting with your application, they are calling the system call to our data OS. The data OS will schedule resources of different data layer and manipulate and help your application to store their data securely and safely. So now I want to introduce why we need to building the data's operation system. This is because if there are many because they can directly use the ceramic network to store their user data. So why we need a new operation system as a middleware layer over the ceramic network and the lead protocol. This is mainly because if I create an application over the ceramic network directly, I will define my database randomly, which means there will be very complex standard inside the data ecosystem. But we want everyone can control their data in one place. The file is a standard in our data's operating system. Even developer create any kind of database, the file is a standard to connect to developer database. So if a developer is creating an application and calling the data operation system, for example, now creating a stream, then the data OS will create an internal file, and the internal file will be stored and connected to the folder. So if users open their personal folder, they will find the file, and then they will find the external stream like your publication data. This is the philosophy behind the data's OS. And the file key is connected with the file and used to encrypt your stream. Another important feature is to protect the application security. If we want to allow users to control their encryption key, now lead protocol is the one option for users to control their key in a decentralized management system. But it is fully based on our digital signature, which means if my signature is stolen by a malicious website, then the malicious website can decrypt all of my data directly from the lead protocol. So we need to divide the decentralized data network as different application zones, so users can securely manage their digital signature, then their data resource and their encryption key can be managed securely. So here is the method in our data's OS. We are trying, now the ceramic and lead protocol is implemented based on the signing with Ethereum and the resource capability standard, which means if I sign a resource, sign a ceramic database, then the website can get the write permission and the decrypt permission and the decryption permission of user data. So, we are trying to use because in our data's operating system, different application has different file system. So we can use the file system resource to serve as the application scope to store the encryption key for its own application. So it is a very complex process here, but more details are released in our GitHub now, so you can check in our GitHub. The last one, I want to show a demo about how to create a social network over the data computer. So what is the main benefits to using the data's OS? The first thing is now you don't need to deploy your own server, and they are built-in data monetization solution in our data's OS. So which means if now I create a post, then the post stream will become an individual file stored in my personal file system. It looks like a file sharing. So you can easily monetize your data file. So you can look in the in the figure. So the first thing for developer is to create a database. Then the database will be connected to the application file system. then the user can use their wallet to publish content in the database. A file stream will be generated by Data's operation system automatically. And if user want to monetize their data, they can publish the stream file as a data token on-chain. I believe in the future, more complex composability can be implemented directly on-chain. Here is more detail. Here is more detail about the how you can create a social network. The first step is to define your business model. If you are trying to allow users to publish content in your platform, you need to publish a post database. You can customize your database by yourself. Yeah, so you can use our Create Data app framework to easily deploy your own application resource to the storage network. Then the second step is for the user to interact with your application. They can create a post in your application. It will trigger a system call, create an index file in the Data's OS. The third step is different users will publish different content over the social network. So how can we fetch all of the content from the decentralized storage network? So you can use the load file on load stream system call in our system. The last step is we also have a design which is about the action file. Every day we will generate content over the internet. But we will also interact with the content which is generated by another user. So action file is designed to implement such a scenario. So if I want to like your content or I want to follow your profile, then a system call create action file will be triggered inside the Data's operation system. Finally, I want to introduce our rebuild ownership hackathon, which is collaborated with the Ceramic Network, Filecoin, Lead Protocol, and the Privacy Scaling and Exploration, and Felix. So the first edition is about digital identity. The second edition is about internet privacy. Maybe the third edition is about the sovereign agent, AI data marketplace related. So if you are interested, you can also join our hackathon recently. Our future is to connect the decentralized database and the smart contract. I know in the Filecoin and the IPFS ecosystem, there are many talented developers and engineers are trying to optimize the performance of the storage system. But in the blockchain ecosystem, the monetization and the tokenization is also very important element in this system. So we want to bridge the gap between the off-chain personal database and the on-chain personal ledger. And then developer can create a more composable product directly on-chain. So for example, like a social file application, like Datadog, like personal cyberspace, and like network state, and even the AI agent. Finally, I want to introduce myself. My background is artificial intelligence based. Generally, data scientists will collect many user data, so AI model will be improved better. But when I dive into the decentralized storage network and the decentralized identity, I'm quite interested about how we can use this technology to allow everyone control their privacy and data ownership. But now, follow my AI background, I'm also thinking how AI agent can integrate the data's operation system. So the AI will become a digital knife which can interact over the Web3 internet. So for example, we can own our Pokemon. So maybe in the future. That's all. If you are interested, please follow our Twitter and join our Telegram group. You can contact me directly via the Twitter or email. Thank you.
Okay, thank you. That was all for this part of those sessions. Now we're going to take a coffee break, and we'll be back at 4 p.m. Thank you.
Hi, everyone. Hi. Hello. Hi, over here. I'm going to introduce our next speaker. We are in Asuka. Sorry, I wasn't ready. We're talking with structured data with IPLD, how to get the most out of your static data with Carson Farmer. Please welcome Carson Farmer.
Cool. Thank you for the introduction. So I'm Carson. I'm with the textile team and Tableland, and we're one of the sponsors. And when we were talking with Boris about what we wanted to do for a lot of these sessions, a big kind of goal was to help teach some of the Dev Connect community about IPFS things. And we've been doing lots of IPFS things this week. And so this is a talk kind of about one of the little things, arguably one of the more important things about IPFS, which is how we actually build up that content-addressed data. And so I'll talk a little bit about that and how easy it is to start doing a little bit more sort of low-level structured data for like building dApps and applications and things like that. So this it's a session for I mean this in the nicest way, noobs to the IPFS space who are starting to get dig a little deeper into what it is that IPFS is. So, at the end of the day, the internet is pretty much just about, well, it's as we all know, it's a series of connected tubes, but it's all about links. And when you're building websites, it's links to web pages, and when you're building links to other websites, and we create this, web of information. And the new version of the internet that we're building with IPFS is no different. It's all about links. It's just instead of telling you where to go fetch that something from, we're going to tell you what that thing that you're going to go fetch looks like. So we use content addressing for that. But it's at the end of the day, it's all about links. And those links are defined by a data protocol called IPLD. And so this stands for interplanetary linked data. Everything has to start with IP, and then you get to call it something else towards the end. So interplanetary linked data. And if you've been around the internet for a while, you've probably heard about linked data. And IPLD is probably the most practical implementation of open linked data out there. It's very simple, and we're going to talk about how you kind of get to that simple data representation over the next couple of slides. But the whole idea behind IPLD and IPFS is to make a better, more connected internet. And we want that connected internet to actually consistently work, even when links start to die and all that stuff. And last night I was talking to some folks that are familiar with Internet Archive and a lot of the archiving and maintaining of information on the web. And we're still at a point where the average web page, lifespan of the average web page is about 90 days. After that, links to it expire, or it stops getting hosted, or you just can never access it anymore. IPFS is a lot about just sort of making those links permanent to the content that it was at some point. Hey, maybe it won't be hosted anymore, but at least things that depend on those links will continue to function and behave and operate the way that we expect them to. So a more resilient and connected internet comes out of that. And so IPLD is a core component of IPFS. And so, okay, what the heck is IPLD? Really, it's just a pretty simple data model for distributed data structures. And that is just a sort of slightly nerdy way of saying it's just a data model for linking data. And it is the core piece that we use to build up our content addresses, our CIDs, those BAFI numbers that we were talking about at the beginning of the day. It's the core piece that we use to build that up and to actually then calculate what is the CID for my particular piece of data. And so we use IPLD and CIDs to do that. That's great, and that's very simple. And if I want to add a file to IPFS, all these things are all happening in the background. IPLD is being used in the background. But it is also, you might call it like a gateway drug to way more advanced operations over the decentralized web. So once we get a handle on what IPLD is and how we can use it and what it's useful for, we can start to leverage it to do a lot more clever things. And I'm going to try to elucidate what those clever things are over the next couple of slides. But it's a way to help us build more advanced applications on the decentralized web. And there are a couple of core concepts that we care about when we're talking about IPLD. As we mentioned, the most important thing about IPFS is it is the content addressable web. It's all about content addressing. And so in that case, data, whether it's a web page or a picture of your cat or a blog post, whatever, the data is identified by what it is, its content. And I'll talk about how we actually calculate its ID from the content in a little bit. And it's about links. So IPLD, linked data. It allows linking bits and pieces of data to other bits and pieces of data. And then through all of those linking, we get this idea of like immutable data structures. So we get these like static, immutable data structures. And I do want to take some time for a second to talk about what I mean when I mean immutable. Sometimes IPFS has been referred to as like the permanent web, or like an immutable web. And that is true, but it's also misleading. Immutable just means that once I've created some version of the data, that version is going to be valid and immutable and unchanging for the rest of time. But that doesn't mean that the sort of like semantic information that data represents is immutable. We can have like dynamic web pages built on immutable data. And so it's a little bit misleading to call IPFS the permanent or immutable web, but that's what we're talking about when we talk about it. And a big piece of what we get from immutability is interoperability. And IPLD has this concept of like data interoperability built in as a core piece. So IPLD can represent all sorts of things that you care about as a developer or a programmer, like lists and trees and graphs and raw values and things like that, as well as links between all of those different things. And so you can interoperate between IPFS, different blockchains. You can actually use IPLD to parse Bitcoin transactions. And you can actually serve Bitcoin transactions over IPFS because you can interoperate between these data structures. So it offers this sort of super duper powerful interoperability layer that almost nobody coming new to the ecosystem really gets exposed to right away. So hopefully that's what we'll do today. It also simplifies that interoperability so that there's very few decisions that you need to make about how I'm going to do this. So if I want to sort of parse the Bitcoin blockchain or data structure over IPFS, then there are very well-defined ways to encode and decode those data structures so that an IPFS gateway knows how to and can understand how to move through the graph of updates or the chain of blocks, if you will. So it's all about interoperability, and IPLD is well defined by a spec. And naturally, everyone will want to read that very technical spec in order to fully understand it. And that was a sort of cheesy joke, but there is a spec defined there, but nobody expects you to read that specification. It just outlines all of the very powerful and important things that we can do with IPLD. But the beauty of it is, of course, it's a piece of technology with a specification behind it, and it's built into a lot of the tooling that you may use when you're working with IPFS. So IPLD is built into IPFS. It's built into Filecoin. It's actually built into lots of other protocols that operate in the decentralized web. Some chat-based protocols, some data storage protocols, like Ceramic uses IPLD. Textile, my own company, uses IPLD. Lots of different chat apps and things like that represent data using these linked IPLD graphs. But obviously IPFS is the most well-known example of this. And the way that IPFS leverages IPLD, kind of the most obvious or first way that people experience it, is they want to do something like IPFS add my data, right? You want to add an image or something like that to IPFS. And you would use the IPFS command line tool maybe to do that, or you would use a JavaScript SDK or a Go or whatever. And what is actually happening in the background is that a bunch of work is happening to take that data, chunk it up into chunks, build those chunks up into a graph, which is an IPLD structure, and then calculate a CID from that and pop it back to you. And I'll show you kind of what I mean about building up a graph or DAG in a second. But all of that is happening kind of in the background when you're using IPFS. And years ago, we wrote a bunch of blog posts about like what's really happening when you add data to IPFS. And those are good reads, but you know, in the next couple slides, I'll kind of summarize that in a much more approachable way. But once you get a handle on how IPLD works and how it is this sort of key component of content addressing on IPFS, then you can start to use it directly and build much more advanced data structures and much more advanced sort of data models for your applications so that you can optimize things that you care about, like even help you optimize page loads so that when you load, I don't know, you're building a video platform, you don't accidentally try and load like all the videos all at once. Instead, you load links to those videos one at a time. So there's a couple of things that I kind of want to mention, right? The first thing I said was that IPFS takes the data, chunks it up, and builds a graph. And what it's building is something called a Merkle DAG. So first of all, a DAG is a directed acyclic graph. It's just a tree structure where there's no loops back on itself. Okay? And that's a pretty important property because it means that we can actually calculate a single content addressed at the root of that DAG or data structure, and we can use that to sort of pass around and represent a reference to this data that we're talking about. Each node in this graph is a hash of its own data, or of its data, and each node has links to other nodes, and we build this up to build a tree, and it looks you know, something like this. So at the top, we have this like root hash, and in the intermediate nodes, this is a sort of hash of the data below it until we get to the chunks. So in the case of IPFS, we actually say take a cat photo, we break it up into sort of specific chunk sizes. That's those data 0 through 3. And then we start to kind of build those together to build this data structure. And then what you pop out when you type in IPFS add is that root hash at the top of the tree. And then you could basically say, okay, I'm going to add that to IPFS, and then you email your collaborator over your image or something like that, and you say, hey, this is the data that I'm working with. Here you go, and you send them a little Baffy blah, blah, blah string. It's like 42 characters long, and it represents an entire image. This is pretty great, and what actually this is an IPLD structure with a root hash at the top, and it has internal links. So this is linked data. In this case, it's sort of like kind of opaque what it does. It's just one, really, you care about the picture. It's one picture, and it's broken up into little bits. But we can also make those links sort of have semantic meaning as well. So maybe you have a data structure where, like your profile photo is a link to an IPFS hash like this. And so you can start to get a little bit more nuanced in what you actually represent with data. And so you might call the process of taking the data structures that you're using for your application, maybe it's like user data or some JSON document that represents your user, and turning it into an IPLD DAG, we might call that process Merkleization. And that's like not a real word, but it's a good sort of descriptor of the process of taking a normal data structure like JSON or a list or an array or whatever, and designing it in such a way that we can create a DAG from that with links and things like that. So the idea of Merkleization is that we turn certain kinds of data structures into a hash-linked data structure that's compatible with IPLD. And ideally, when we do this, we don't use our brains to actually have to think about this. It should just happen really automatically and easily. And pretty much all we need to do is we just replace pointers in our data set with hashes or pointers to hashes of other things. And that's pretty much it. So I'm going to try and show some examples to illustrate this a little bit better. So imagine we have this very simple JSON data structure here where it's an object, it has a pointer to some other object. In this case, it's an object that has a hello key, and the value for that key is world. Okay? Now, we could do something way more complicated. Like instead, it could be a JSON document that represents a user in our dApp. And so I don't know if anybody here is going to be hacking in the ETH Global Hackathon this weekend, but you're probably going to have some kind of data structures that represent users or represent information, and it might look something like this. Okay, so we will use an example straight from the sort of Helia implementation. So Helia is a JavaScript implementation of IPFS. You may be familiar with it. If you're building like an application or a dApp or something like that, it's probably the first thing you're going to reach for. And it's pretty easy to use nowadays. And so here's an example of how you would do that. So you would, npm install Helia, and you import it, and you're going to create a Helia node. That's basically saying I'm going to create an IPFS node. And in this case, I want to be able to add some JSON data to it, sort of semi-structured JSON data. So the first 4 lines of code there are pretty much just setting that stuff up. And then what I want to do is I want to add my data to IPFS. So j.add, and I'm going to add the whole data structure to IPFS. And I get back that root CID that represents that whole piece of data. And if I then go and fetch that from IPFS, I get back the thing that I created. Wow, okay, IPFS sort of works. That's great. So far, I haven't taken any advantage of the fact that under the hood, this is all a linked data structure. Right now, I've just basically created one little bit of data that has a link to something that I already defined, a JavaScript object. So we've still got pointer is a pointer to an actual object. So what we can do is by adding one little step, we replace our pointer with a hash or with a link to the underlying data. And again, this is a sort of like, I don't know, you wouldn't really necessarily need to have a pointer to like a tiny JSON object that says hello world, but it illustrates the point fairly nicely, which is, okay, what I'm going to do is I'll add this first object, hello world, to IPFS, and I'll get back an immutable CID or address that represents that underlying data. And then I'll create a new object, and I've replaced the direct pointer to that data with the hash, the CID. And then I'll add that object to IPFS. And then what I can do is go and I'll fetch that back again. And what I get back is an object where pointer points to a CID, a content address, that represents a reference to the underlying IPLD data. And then I might take that CID that I get and go fetch that thing in order to actually get the underlying hello world thing. Now, replace hello world with link to an image or a profile picture or something like that, and you can start to see why this could be potentially useful when you're talking about user data. Because I don't necessarily want to go and fetch user data if it has a bunch of images in it. If I'm on a given page load, I might not actually need that image yet. Right? So you can start to imagine that I can hyper-optimize my data structures in my application so that I can fetch the data only when I need it. But the whole entire data structure references all of the things that I could potentially need for my user all in kind of one place. And so you can sort of start to realize you can make sort of very lazy data structures. And this is just the default simple IPFS API. And in this case, I'm just interested in like JSON data structures in this particular case. JSON data structures with links. But there's so much more that you can do with IPLD if you want to start paying attention to actually creating these links and things. And another key piece of IPLD, something that's quite important, is it provides canonical encoding for the underlying data, so that when the an IPFS gateway goes and fetches data for you, it knows how to decode that and show it to you in a way that you're expecting. So that if you create the same JSON object and calculate its IPLD structure, calculate its CID, no matter how that thing is defined, you're always going to get back the same CID. And that's kind of an important feature of the decentralized web, is in addition to being like sort of hash-linked data, we also want those to be deterministic hash-linked data structures, so that when I ask for something, I get back what I'm expecting. And so IPFS has sort of built-in assumptions about how you want to interact with IPLD, but all that underlying IPLD stuff, you can have access to that directly. And so actually at Textile, we spend a lot of time working with like IPLD and libp2p and some of the underlying libraries that are used in IPFS, but I rarely actually interact directly with like Helia or Kubo or any of these common IPFS implementations. Often I reach directly for the underlying piece of tech that I actually need. In this case, we're talking about IPLD. And I'm using the JavaScript APIs and libraries because that's what a lot of DevConnect developers are interfacing with, and so it's useful to have that type of example. But here's me interacting at a very low level with IPLD. And in this case, I start with a value, hello world again, and I might want to take that and essentially create an encoding of that as an IPLD structure. And that structure in the JavaScript case, it includes the value itself. Okay, so I've got hello and I've got world. But it also includes the canonical byte encoding for that using DAG CBOR, which is an encoding or a codec that we can use to encode the data that we actually care about. And so if I did this or you did this or someone else did this, we'd all end up with the exact same encoding with the exact same CID because it uses SHA-256 as the hash, and it uses CBOR as the codec, and we're all really happy because we know how to interoperate. But here's what's really neat and really nice about IPLD is maybe in your application you want to ship data around as JSON because you're a web developer and that's the sort of thing that you speak. But I'm operating in a Rust-based environment and I want to use CBOR because it's a binary encoding and maybe that's nicer for me to think about. Well, you and I can completely interoperate because at the end of the day, we're talking about a higher level IPLD data structure, and it doesn't matter which encoding I initially use, as long as I tell you what encoding I've used, which IPLD helps us with. It's sort of a self-describing data structure in that sense. Then I can ship you JSON CBOR, and you could decode that into, JSON IPLD, and you could decode that and then encode it back into CBOR, and we can move all these things around in different data formats so that you can hyper-optimize for your particular application. And at the end of the day, we'll get different CIDs because we're using different encodings, but the same underlying data we can always play around with and we can always access. So encoding is a pretty important part of how we actually interoperate with IPLD. And IPLD gives us a lot of control over how we actually represent our data structures. And I was kind of getting at that with the first Helia examples. Here's another example using IPLD a bit more directly, where we take that exact same example where I take a value, I encode it into a block, I then make a pointer to that underlying data using its content ID, I encode that, and then maybe I transmit that using my super awesome peer-to-peer chat protocol. And so, hypothetical wire or storage protocol that I'm using to transmit data. Maybe I, transmit the raw bytes. Maybe I transmit the CID, and then I get you to fetch the bytes over IPFS. However I want to ship this information around, we've got a canonical sort of representation of it that we can talk about. And then on the other side, I might actually then go be able to fetch it. And I can do this fairly lazily, which is a pretty nice feature of linked data. And it's kind of like when you click a link on a website, you don't load all of the internet all at once, you just load the little bits that you're looking at any given time. IPLD is no different and adds that sort of capability right into your underlying data structures. So here is an interface or an API that IPLD supports, which allows you to just, for a given chunk of given piece of IPLD data, I want to just go through all of the links that it contains. And I don't want to have to think about I don't need to know that the link was under something called pointer. IPLD just exposes all of the links in a sort of agnostic interface. So I can get a chunk of data, and if I know it's IPLD, I just say, okay, give me the links. Or for each link, I want to go fetch the underlying data that link represents. So I have a lot of control over how I actually access and interface with that data. And if you've ever looked at, say, IPFS data over an IPFS gateway, and it contains like links to files, this is essentially what you're doing. You're traversing those links, and the gateway is actually going out, checking, finding all of the links and putting them on the page for you to click on. So in this case, I can walk a given piece of, given IPLD data structure and use some hypothetical fetch block by CID function to go and fetch the block and maybe keep a tally of all of the chunks of data that were in the data structure I was parsing or whatever I might want to do. And so you can lazily fetch data and you can sort of expose these generic APIs in ways that make it really flexible to build applications on top of. So we can get kind of lazy, and that's what developers want. We want to be as lazy as possible and get the things done that we need to get done. And so I want to keep this talk pretty short. I have lots of time, a little bit of time left for questions, but I'll finish up with, okay, this is great for like sort of static data. What about dynamic data? And so this is a warning, this is a bit of a shameless plug, but I work for a company called Tableland Textile. We have a product called Tableland, and Tableland is specifically for that like next phase where you have like highly dynamic data that you want to be able to query in dynamic ways. So it's like a cloud database that's decentralized, and that plays really nicely with IPFS and with IPLD and with CIDs and fetching and things like that. So imagine like a fully compliant ACID database or ACID compliant database where you can do things like, inserts and updates and selects and queries and fetch this, where that kind of stuff, but all mediated by blockchain, smart contracts, and things like that. So you could do crazy things like only allow users that own my particular NFT to insert a row into a table, for instance. And then select that out, and by the way, there's a row, or there's a column in that row that represents the user's profile picture, and I want you to go and fetch from IPFS that profile picture while you pull that query out of the database, and crazy stuff like that. Pardon me. So this network is live on a bunch of different blockchains. If you are a hacker, chances are you're using something like Polygon or Optimism or some testnet. Tableland is there. You can play around with it. You can mix Tableland with IPFS. You can do all sorts of fun things, and I highly recommend you do that and play around with it. And here's an example of how you might do that from JavaScript inside of your application. And as you can see, it's pretty much just SQL queries and SQL statements and things like that. So imagine a world where you can like sort of hyper optimize the underlying data structures that you are using, encode that into some binary representation, stick that into a table to index it, and then be able to query and slip and slice and do whatever you want with your data, so that you can write an application kind of in the way that you would want to write an application. So shameless plug over. Go check out tableland.xyz for some docs and things like that. Thank you for coming to my talk. Hopefully you've learned something new about IPLD and how easy it is to optimize your developer and data structures while you're building your next hack, this next hackathon. Thank you very much. And yes, it's just me up here, but if there are any questions, and they can be like beginner questions too. That's what this session is kind of all about. So put up your hand, and if you don't have any questions, it will make me look bad, so one question would be great. Yes?
Hi. So you mentioned that we can use IPLD to access various data sources. I am not sure because I haven't used that part. I have the idea that if the data source is outside of IPFS, like the Bitcoin blockchain or something like this, you can reference the data, you can reference a transaction or maybe a block, I don't know, but you cannot actually access it unless you have something that I don't know, a miner or something like this, that can access this piece of information, this piece of data?
Yes, that's a great question, great point. Yeah, so you can reference things with IPLD, and that's all well and good, but you can't access it unless you have some way to resolve that reference. So that's the key piece there. And lots of people have built like IPLD resolvers for like Bitcoin and Ethereum blockchains, and even Git and other like sort of linked data structures that you might be interested in. But at the end of the day, you need that. I think you need that fetch block by CID resolver in the loop at some point in order to actually go get the data. But the kind of fun thing here is, and this is something that certain apps and applications have used as a sort of feature of IPLD, is you can reference data that isn't actually available, but could be available in the future, as long as you know ahead of time what that thing is gonna, like the content of that thing. So a great example of this, because that was very kind of like opaque response, but a good example of this is sort of in a world of like commits and attestations and things like that. So maybe you want to reference some signed document or contract in some data structure that you're working with, but you don't want to reveal the contents of that document right now because it's not relevant, or because you want to keep that information private or whatever. But what you can do is you can say, okay, like in the future, if something comes up, someone violates the contract, we can say, look, here's the contract, and you can verify that it is the contract that it should be by looking at its hashes and all of its links and things like that. But I'm only going to reveal it when we actually need to like implement the contract or like bring it up or something like that. So there is, there was a chat application that allowed you to share photos, but you didn't want to necessarily put the photo on IPFS to be publicly available. So you can reference the photo and then do like a direct peer-to-peer connection to actually share the photo itself. So that resolver piece, can be kind of taken out of the loop or customized or changed in a way that you don't get with just putting things on IPFS. But thank you. That almost felt like a setup, but that was a great question. Yeah.
Thanks.
Okay, that's pretty good. Thank you very much. Thanks for coming. Now, there's lots more, so I gotta go to another talk. There are lots more sessions happening today, and then we'll do a summary back, community summary at 5. So be back then. I gotta run. Sorry that I have to miss you.
Yeah, no worries. Yes, I'm putting it in there.
Can you go into your display settings?
What you need?
Can you open your computer settings to display?
Yeah, this is it. But I'm not seeing it.
We're going to be dragging the slides to the right. Can you put on the music?
So the slides to the right.
Yeah, the whole browser.
So it's 2 different windows. Should I move the slides or
The slides to the right. Yeah, and you can make this.
Oh, hey, I am not ready. There we go. Yeah. All right. Welcome, welcome. My name is Edward Hibinet. I do protocol architecture for DeSci Labs. This presentation is going to be a bit about how we choose to implement our underlying data infrastructure for the open protocol that powers our applications. So specifically, we're going to talk a little bit how we can solve scientific publishing problems with IPFS. So what we're doing is we're building tools for a radically transparent scientific record, and we build web apps to help researchers create persistent research publications. In the long run, we want to make sure that we can safekeep and navigate the collective human knowledge. And I'm not going to focus too much on our product in this talk, but rather kind of what DAG structures we need to be able to express for any of this to work. So we're going to see how we use IPFS and IPLD to publish, organize, find, and interact with scientific data. And to give you some context about what I'm kind of going on about, I will quickly show you kind of how the application looks so you get like some context. So what we have here is the web portal that the researcher will use. So they will upload their paper, their data sets, their code, and this is the way to kind of see that. So to the left, you have basically a Google Drive style file tree. In the middle, you have like the front matter of the paper, and then you have like attestations and the activity log. So basically the versions of the publication that the author has created. So let's look at some background, like how this is currently built, and later I will kind of show how we are gonna like transform it in the next generation of the protocol. So at the base, we have something that we call the research object, which is kind of what we just looked at in the front end. This is represented as a manifest file around the Unix FS DAG root. So the content of the publication is what you see in the tree. So you have like a directory called data, which has a SQL database and some CSV data, and you have a docs directory. To add context to this, because just these files doesn't say much about the scientific publication that it kind of represents. So to accompany that, we have a manifest file, which has an IPLD link to this tree. This holds the like science context for it. So like the title of the paper, information about the author, which research fields it's a part of, the contributors, which license it's under, and et cetera, et cetera. But there's an issue here. What if the author wants to update this and add a code directory to this file tree? Because as we know, like this would change the CID of the data structure and hence also the CID of the manifest file. So how do we keep track of this? How do we like solve the versioning problem? So the way we do this is we bind the manifest CID to a unique key in a smart contract map. So basically, you mint a little like access token, which gives you control over, let's say, the key 45 in a mapping. This allows you to like authenticate yourself for updating the linked manifest file. So when you do that, we emit an event, and through tracking these events, we can build up the history of how this publication has changed over time. So this hits like almost home. There are some issues with it still. Like this works, we use it. That's kind of what we have deployed right now. But there's a single data type, and that is the research object. We want to be able to like track contributions of many different kinds, so we need more data types to keep track of. And there's also the issue that a single author controls all of the context for the publication. So if all the metadata, for example, about the content of the research object is in this manifest file, which means that only the original author of the paper can update the metadata. There is also no like natively linked history in the IPLD sense, because we like implicitly compile it from the events from the updates on chain. There is also the requirement of a smart contract transaction every time the author needs to update the publication, which is quite a big UX hurdle, because for the space that we work in, the like traditional scientific or academic community have a very low tolerance for like crypto balances and like seeing tokens and managing gas and stuff like that. So these are basically the issues that we kind of need to solve with the next iteration. So we have needed to rethink the underlying data layer on how we're going to represent the content here. So I've worked on defining a protocol for a collaborative open data graph to be able to represent all of these publications and the scientific context around it. So I'll take you through the abstract DAG requirements that we need to express this data and how we ended up building it. So as a first naive idea, if we don't want to track them on chain, can we just toss them onto IPFS? There is a IPLD structure called DAG Jose, which would be a way to kind of take the manifest file and then sign that whole bundle of data with the private key of the author. So doing this, if you looked up two different DAG Jose objects, you would see that they are signed by the same author, so we could reach verified authorship. However, these don't share an identifier, so these are two loose points floating around in space. There is no relationship between these. There's also no historical lineage, so figuring out which one came first, what is the newest version, and we can't just put a link to the previous one, because then when you create the third version, you could just also create new objects to kind of replace the history. So we have no way of actually knowing whether or not the history has changed without kind of trying to find all of these and then trying to map out what's the truth. There's also no way to discover these as they happen. So the author publishes an update. How would I know? That's really tricky because IPFS doesn't give us the tools to do that. So from this, we kind of realize we need a way to chain these updates together into some structure. So we've implemented this with Ceramic because what it gives us is a way to represent append-only versioning under a shared identifier. If you know about IPNS, or the Interplanetary Name Service, naming scheme, where you can have a mutable pointer that points to content addressable storage blobs, but with a versioned history. So basically seeing where did it point before this and where does it point now. And this is what Ceramic does. So all additions to the history need to be signed by the original DED to be accepted by the network. We get an umbrella PID, which is A here, identifying this entire chain of updates. We also get the historical lineage as a stream of commits, because the network won't let you add a commit if it doesn't build on the same history that the network knows the stream state to be. Through this, we can resolve anything. So we can resolve a specific, that CSV file in version 0 there. We can go identify the stream, find that specific commit, and then slash our way through the UnixFS file structure to find that particular file at that specific version. And this is exactly what we need to track the version history. However, we still have one key issue, which is how can we resolve and discover new instances of research objects? Given a single research object, we can find all of the updates, but how would we find a completely new one? How would we find B in this case? So we need a way to find data instances from the schemas that they implement, and this is what ComposeDB adds to Ceramic. So we create a schema for what we consider to be a research object, and then we can query what, ComposeDB gives us a DAG of instances following the schema that we can query to find all of the data. So we can discover instances made by the model regardless of where and when it was created or by whom. So all of this information is accessible over IPFS, but we get a contextual DAG over the relationships between them and the models they implement. So we forgot kind of about one thing. So the original manifest file that contained a lot of different types of metadata. So about the author, the research fields that it was part of, annotations, metadata. So we've kind of lost track of that. We could add them into the model. So put them as schema entries in the research object, or we can just keep them in the manifest. So the way we've kind of split this together, split it apart, is to create models for the different types of contributions you can do to build up a more complex graph or more expressive graph of how entities in this data layer kind of relate to one another. So with subcomponents, you can have more granular contributions. And like this diagram shows you like a user profile. You can see 2DIDs have their own profile, implementing the profile model. And through ComposeDB, we can find these instances. You can see that both DIDs have created their own research publication. So like RO there stands for research object, which implement another model. You can also see that DID2 here has assigned a attestation by creating that model, and it includes a reference to a specific version of the research object that the Professor Fig has created. So like everything here is granularly creditable, versionable, verifiable, and automatically discoverable without having to rely on any like central party. We can do relations in this through using these persistent identifiers. So either we can reference the stream itself, which basically would resolve to the latest state, so like the latest update by the author, or we can refer to a specific commit, so like a specific state at a point in time if you want to have it like deterministically resolvable, which is exactly what you want if you want to do a reference to a particular scientific paper, for example. So another thing that's really cool about this is how it's extensible by the community. So each of these models are independently indexed, which means that the community can create extensions of the protocol. So they can create a new data type and create new types of references, which can be found by everyone participating and like being interested in finding this data. So for example, let's say someone starts to encode publications with semantic embeddings, basically allowing you to like chat with an LLM to like learn about the content of a publication. Someone can create a model for this, which they instantiate and add the embeddings from a particular paper and use a reference to point to that paper. Anyone who is interested in having these embeddings can start indexing this model and enjoy this new type of context that's suddenly available. And this is without any type of like governance. There doesn't need to be like a central decision like in a DAO. Anyone can just like create this model, start using references to this research object, and just like add a completely new type of context. In the same way, let's say the data layer kind of evolves. We want like a new way to represent something. It's the same there. You can just add that, and they can coexist. We can support both, and you can practically deprecate, as in like stop creating new content with the old model, but they can coexist. There needs to be no like formal upgrade decisions or anything like that. So we talked a little bit about context around the publication, like the research field, for example. That's something that's not unbounded, like you usually have like a couple of research fields. But metadata in the scientific community is like a bit weird, and there are 3 magic words for being compliant with all of these like open science standards, and that is metadata format agnostic. If you are not metadata format agnostic, like you basically don't have anything in the eyes of the kind of open science metadata community. So this makes it quite hard to put in the models directly on the network, so we need to like link it in. Like the reason for this whole thing is to ensure that the publications and their metadata is forward compatible for like machine actionability and basically any type of information that could in the future be useful to have associated with a publication, like retroactively. This means that we can put no practical limit on either the size nor the format or shape of the metadata. So we can link them in. So like the manifest file at the root of the publication could have a link to a CID, which would hold like a whole bunch of metadata. But we want the participation. We want people to be able to granularly contribute with metadata. So this is one example of how we can do this. I made this figure really, really big because I thought the screen was going to be small. But now we have a huge diagram. So basically, an author can add context to a raw DAG node within the file tree that's associated with a research publication. We use something called a research component model to do this, where you can add some information. So like here, they tagged it as like flight data. You can also like use some useful for like curing or useful for discovery stuff in the component itself. But then you can add like the bulk of the information as a link to a CID to a JSON file containing basically an unbounded amount of arbitrary metadata. The community can kind of extend this and suggest corrections or additions by creating an annotation targeting this component and linking in a JSON patch. It doesn't necessarily need to be JSON. We can call it like, any patchable, serializable data if that feels better. So this works, but there is like a canonical metadata file, which like it's kind of the truth, and then you have like a bunch of suggestion. Me personally, I think it would be very satisfactory if we could just see this as like a sea of metadata shards. This is another way to do it. So like basically removing the difference between an author's own definition of what is like the metadata for a publication and putting it at the same level as the rest of the community that can contribute metadata. This means we can like remove the metadata king and just kind of have a floating sea of information around it. So how this would work is that the original author can, again, like tag the nodes of the DAG with JSON like CRDTs. So this is conflict-free replicated data types, which is basically a way of representing. It's kind of what underpins stuff like Notion and Google Drive. So like you can have concurrent edits, and it's kind of guaranteed to converge to the same state. So by doing this, you could like compile the metadata after some arbitrary filtering or selection. So let's see, like what is the metadata if we compile all of the contributions from just the author? And what is the metadata as provided by other community members on the same research object? Or we can filter it in like, I just want the metadata from authors active, like that have published paper within the biotech community, for example. So this will allow you to like very granularly select what you think is the important like subset of metadata for a given situation. This is extremely powerful. There is like no way of managing metadata for scientific publications that can do these types of things. I realize I went through this a lot faster than I had planned, but that just means that we have plenty of time for questions. I'll just mention that this like open data layer protocol type thing is what we call the DSI Codex, which we unveiled last week. You can find the documentation on that to the link up to the left. Check it out, hit me up. I would love to discuss this stuff. And I hope this was interesting and or fun. And I want to thank you for your time. Got some questions, perhaps?
Hi. So you presented us a version that, from what I understand, is the previous version of this system, where you used IPFS or IPLD and a smart contract, correct? And then you moved to a new version where you have the IPFS, IPLD layer, and you use ceramic. The way I see it, maybe I'm wrong, is that the new version of the new model does not provide the same level of assurances as the previous model. I mean, if I had to bet who will be longer around, because we're talking about scientific papers and scientific information. And I had to bet for a blockchain or ceramic. I would bet for the blockchain. Nothing against ceramic, I think it's a great tool. So what's your take on this?
Yeah, that's a very good question. The fact is that all of the content that Ceramic manages is stored on IPFS, so it's accessible through IPFS. So it's basically just a way of kind of managing how it gets created and how it's linked together. But the storage, like the underlying storage assumptions and the linking assumptions are the same.
Without ceramic?
So with Ceramic, we get what they call stream IDs and commit IDs to find these things. Like, as long as someone pins this data, you can still find the same relations. But for short URLs, which are kind of important in this field, we're still going to use a smart contract to give short identifiers and connect those to the identifiers for the Ceramic streams. There are a couple of reasons for this, but honestly, mainly it's because short URLs is an important design requirement for this field. Okay. But we can do an important change, because the smart contracts in the original version, that requires the author to have publication access to be able to update their own key in the contract. What's cool about this is that they can just create a stream where the commits will be the updates. So we have one identifier that's never going to change for the publication, which means that we can trustlessly relay to anyone else to create this entry in the smart contract for you. So basically, if you do it through our platform, for example, we will just register you for the short URL. We can do that, and we can't trick you in any way. Either it points to your CID or it doesn't. So it still allows us to completely remove the need for the end user to interact with the smart contract. Okay. And we get the same kind of findability properties.
Thank you.
What type of researchers are the early adopters that you've observed so far?
We do have some. So one is a prominent planetary science researcher at NASA. We have one very famous geneticist who has been, it's been a very good use case because that field has a lot of large data sets that they have a lot of issues sharing with each other. So for example, the genetics data set has been generated over millions of hours on a supercompute cluster and contains 135 terabytes of genome sequences. And that's locked behind a very low egress bandwidth line on a university data center. So basically just saying I want to have this data. If you manage to have the disk space, which is unlikely, it takes you 380 days to get it out. These aren't time frames that are that fun to work with. So by storing it on something that's compatible with content addressability, you can also use stuff like compute over data networks, like Bacalhau and a bunch of similar technologies, to basically, instead of getting the data to run your code over it, you would just send the code and run that over the data where it's being stored. And this is this solves a lot of problems for these researchers. So yeah, we're basically initially targeting researchers in a wide variety of research fields where the common denominator is that they have a large dependence on big data sets and they have issues sharing it with the community. And yeah, communities where data sharing is important.
Any other clusters of researchers that you're looking at now? As in within that area, anything also specific that you're now kind of outreaching actively to?
I didn't really catch that.
So in that area of, you said that there's a particular, almost like a prototype, they have big data and they need to run analysis. Are there any other, are you doing active outreach to them somehow?
Yeah. So the focus now is kind of what we call white glove onboarding. So basically showing scientists that are prominent in their respective fields how to use this and offering help to them to like convert their paper and build up a reproducible representation of it using this stack.
All right, cool, thanks.
All righty, thank you so much for your time.
Thank you so much. Good. Thank you so much. Hello. We have reached close to the end of the day. So what we're going to cover is that Carson is going to run a mainstreaming IPFS and sort of community jam session to end the day. We're going to reserve time at the end of the session. We'll actively ask people to shill stuff, but Carson is going to kick us off with a few little things, and we're going to try a little bit of like fishbowl format. So we're not going to run mics, but if you want to join the conversation. So how many people in the room have heard of the fishbowl format? One. Amazing.
Can you explain it to us, Boris? Because I have not.
Absolutely. So basically, exactly. So basically, if people would like to speak, they come up to the stage and get handed the mic and sit down in the chair. We fill up all the chairs until there is one chair open, and then first one in, first out. There's another person, they sit down in the empty chair, and the other person sits back down again. And it gets a flow for rather than having people over there and people over here, we just get a nice flow as people enter the fishbowl in different ways. I'm going to sit over here and kind of sort of moderate, and Carson's going to kind of moderate, but I'm going to mostly shut the hell up when I stop rambling. Take it away.
Okay, yeah, thanks everybody for coming to this sort of like, I don't know, this is going to be a meld of a planned session and our last wrap-up session and our shilling session and our end of the day thing. But if you do come up on stage, you can have one of these exclusive posters that are not also available down there for you to take as you leave the stage. So there's some incentive for you to come up. Local artists, very exclusive, never before seen in the real world. So there you go. Come and get one of those. But what we'll do is we'll start. The premise of this session is sort of like mainstreaming. I think we call it mainstreaming IPFS. There's a bunch of people in this room who have strong opinions or not strong opinions. It's a safe space here to chat about that stuff. And some people I've like secretly tasked with they have to come up later anyway if it gets sort of awkward. And I don't want to talk the whole time, but yeah, come on up if you have some thoughts about like how do we take IPFS from something that I think I'm supposed to use when I'm building my NFT smart contract thing or my peer-to-peer chat network to maybe just like the only way to build decentralized applications. It is the tool to do this sort of thing. And I think, we don't really hit you can't really call something mainstream until you don't really notice that it's there. If I think about things that are now mainstream, it's things that you reach into your pocket and you open an application on your phone and you didn't even realize that you were doing that thing. Or you're a developer and someone says, open your IDE, and you don't think about anymore what that IDE is. You don't make a choice that it's going to be Vim or whatever. It's just going to be this thing that you use. That is the sort of point we're trying to get to, I think, with the stack that we're building. And it might not be the stack that we have right now. It might be the stack that we're building forward to that we're going to see in the next 2, 5, 10 years. But at some point, we want the technology to kind of disappear or become ubiquitous. So I'm calling out to the people in the room to please come up on stage. Don't be shy. If you've got some thoughts about how we make IPFS ubiquitous, how we help it to disappear, that would be great. And I'll wait about 5 seconds before calling on someone who maybe doesn't know I'm going to call on. Come on up. Yeah, you got to come up. We've only got one mic, and it's in my hand.
I don't know if you can take him. He seems big. Oh, you don't have to fight. Right.
Yeah, you don't have to fight for it. I will give it.
So Travis and I joined this ecosystem because we were application developers, and we're really excited about building end-user applications on top of this stuff. And so I'm going to show something actually that Boris and I have been talking about for a while. Boris has probably been talking to other people about it too, which is sort of account-centric standards for the ecosystem. Like we've got UCANs that allow for some sort of delegation, but right now, Web3 Storage uses UCANs, WinFS uses UCANs. Their accounts still don't interoperate at the account level. And so like, what does a standard look like in this ecosystem so that when I, as a user, log in and I want to see my files, I can see them on any IPFS implementation, and they're tied to me in a way that like I still have permissions, I have access control, I can, as an application developer, build, you know, an interoperable drive, or, you know, I can log in and see whatever. You know, I'm at the foundation now, working on social impact projects. Those social impact projects, very few of them have the technical capacity to interact with the network as it currently exists. You know, a lot of them need something simpler. You know, the activists around the world who just need to like upload some files in a censorship-resistant way, a lot of them are still okay with Drive or Dropbox because from their perspective, hasn't gone down, they haven't had problems with it, and they can use it in a way that, you know, our applications, even though things are interoperable at a CID level right now, they're not interoperable at a user level. So that's my sort of pitch for something that, as an ecosystem, it would be great if we set more standards around.
Anybody got a challenge to that? Oh, here we go. Look at that.
In my opinion, the best way would not be to attack the decentralized market right there, but like I think IPFS could make even more sense in the centralized cases. So, for example, it's like Torrent is a content address platform, and it's a very cheap way to share files with people, and like that's a good argument why centralized people want to use the content address things. And so, I think in like many centralized applications today, we could like make them Web 2.5, where the database and compute is still centralized because it's easy. But then we can use IPFS for the assets and transfers. And then if IPFS is like the thing you use to transfer your Web 2 assets, jumping to Web 3, where we also decentralize the data structure using something like IPLD or another solution you like, could be like easier.
So I was censored when I was 18 years old, and that's probably driven like a lot of my work on the web and on the internet. That combined with my love for organizing things. And I think we have a censorship-resistant internet stack. We make it impossible for people to use it. So we have a lot of components, and just like that talk this morning said, thank you, Hannah. We need to build more systems, right? So. If we can take all of our Legos and package them up into sensible, coherent, really attractive, beautiful systems, I think that's what we need to go beyond the people in this room, people who love protocols for their own sake, and get to like real big global business and humanitarian use cases. So package up the stack of things that are for decentralized web publishing. Package up the set of things that are for version verifiable data, and give that to the AI boom that's happening right now. All those APIs, all those companies, they're changing like 100 miles a minute, and you're not going to be able to rely on those APIs for more than 9 seconds. So they need a base of reliable data to build on, right? So they don't, you don't lose all of the work that they've done. Like, this is a perfect moment for us. Package up all these components into beautiful, fast, seamless syncing. Whatever problem you want to solve, I think we need to do better packaging of our project, and then bring those packages to the various software communities, technology communities all over the world.
Anything I had to say? Or why am I here? What do you want me to say? Express myself. Okay. If people want to use IPFS, if you have a library or a tool or anything that uses HTTP already, I really recommend to just go for your passion, build IPFS into a tool. It can take like 2 years before you get there. I'm one of the people, as in, who made IPFS available in Girl. That took 2 years. It's just 2 years. There's another project called FFmpeg that took like half a year. I might start with rsync after this one, but I don't know for sure if it takes like another 2 years or 3 years. But anyhow, if you have like projects that want that already support HTTP, there's a bug tracker as well that tracks like interesting projects that have the potential to be IPFS enabled. So register your project there or file bug report, and we can see if we can implement another one.
Can you just say that again? There is a list?
There is a list.
Where is the list?
I don't know the link just off the top of my head. It's yeah, BFAY, XY, no, I don't know. There is a GitHub list somewhere about, I think it's called IPFS integrations, and then you have IPFS integrations. Okay? So,
Amazing.
That's it. Or wait. Does anyone have any questions about IPFS implementations? Who wants to build an IPFS implementation in like tooling or libraries, or am I the only one? Could any of you like name an application or library that would be your first preference that would have IPFS support, if it's up to you? Scheme? Git?
Mastodon.
Yeah, literally.
That's perhaps a little bit more difficult than just a library or a tool,
Your
but
fishbowl
sure.
panel takes over the whole room. Sorry.
Browsers.
We have one.
Let's make a browser. Okay.
Over to Danny.
So I find it very hard to form habits, which is a shame because I have loads of really good habits that I would like to have. And one of them, I would think about a lot is like I would set up this habit where I would set up on Fiverr or Mechanical Turk or whatever, and all I would do is like pay someone, I don't know, a Filecoin or whatever, to install and run IPFS. And I would just like get to record them, and then I would look and see what happened. Just do it every day. And I always think about this at 3 o'clock in the morning, and then the next morning I never actually do it because it's a little bit weird, right? I'd like to watch you install IPFS. But I think we would learn. I think we would learn a lot. I do kind of do a variant of this that whenever someone on Hacker News or Reddit or something says, "Oh, I used IPFS, but like I don't use it now. You know, I tried it out and I didn't like it." I try and ping them and say, "Can we talk about it?" And usually it's not. They really love the idea. They're really into it. I think there's still there's a huge amount of popular support for the idea of IPFS. You know, when I see somebody say that, it's usually in the middle of a discussion where people are talking about how cool IPFS is. And when I ask them, they say it's because of the high CPU. So they download Kubo, and they run it for a bit, and it takes up a lot of CPU, or it takes up a lot of network connections, and they turn it off. I think if we're crossing the chasm, my guess is there's probably an option people can set, right? There's probably something that would minimize that, but that, if I was to give you something to do, it would be when people take Kubo out of the box, even though we called it Kubo, they still download it and use it. If it didn't jump in CPU, I think we would get more people, less people bouncing off. That's just my thing.
I think those people should check out this IRO thing. I hear it's pretty good at resource management. I think that my take, how do we get to mainstreaming, which is put together, to the thing Michelle was talking about, put together a set of, you know, Boku components that go together in such a way that they unlock something. And this is where you have to prove that you can unlock something with these decentralized technologies that's way better than what exists before. And there's examples of this. Like, I think Filecoin is a great example of this, right? Like, yeah, you know, it's not like everything's perfect, but they put these technologies together, and in a year, they had exabytes of storage capacity. You cannot do that with centralized technology. So we have sort of the same graph with Filecoin Saturn, where we were able to grow this network in a year that rivals the speed of networks that are 10 years old, right? And like if you look at the like current IRO demo, you can like have two computers next to each other, and one like uploads a movie and the other one can immediately start streaming it. It's because you've got this peer-to-peer layer, right? And they've got all this technology for, you know, doing that kind of streaming seekable requests. So to me, it's like find a way to put the parts together so you can do something that the other people can't do. And if you don't do that, then, you know, I mean, you know, maybe people will use it, but I think that's compel people to use it because they need to do something that only you can do. Yeah.
Thanks, Anna. I think that was great and took a lot of the words out of my mouth. There's a couple of thoughts that I have, and I've been thinking about this a long time as a developer advocate, just kind of like surveying the ecosystem and having a lot of these conversations over the years. And so maybe let me start by saying that when I was a teenager, I got into music production. Ableton was just kind of like coming up at the time, and it was a really exciting time to be making music because computers were strong enough to really make you be empowered. You could do a lot of synthesis, and at the time I was so excited, and I got a bunch of MIDI controllers, and I was just wiring it all up, and I realized that I didn't have enough of a music, like a formal training in music to be doing a lot of this, but I got kind of far, and I was speaking to a musician friend of mine, and he told me, I think you're too busy with the tools. You don't have an idea of what you're trying to create. Maybe try to flip that around, try to have an idea of what you're trying to create, and then find the right tools to do that. And so I think if we're really talking about technologies that are empowering users, that are increasing their users' their agency as agents on the web, I think it's important to look, who are these users who are joining the web? Where are they? And if you really look at where we're seeing increased internet proliferation, it's in places that didn't have internet prior, places like Africa, places like India. These are also, interestingly, just as a sort of side note, places where they don't have a demographic problem. These are the only places in the world where you're still seeing an increasing population. And so I think there's something really interesting about those places, especially because many of these users are joining the web directly on mobile devices. So a lot of these folks have never even used a desktop. And so what does that mean for us? I think, there was a hint made about, resource consumption. If you think that getting IPFS into the hands of, 5.3 billion internet users using Kubo, I think that's going to be futile. And so we really need to be creative. I think we can't be beholden to our past. I think we need to be willing to make some bold moves in order to get IPFS into the hands of more people, really as a tool to solve problems, as you said, Hannah. And specifically, I think, at least if you were to ask me, one of the biggest bets that I'm willing to make is that for it to be mainstream, for IPFS to be mainstream, we need to bet on the web platform, because that is the common denominator that brings together all internet users. So I'll leave you with that.
Thanks, and I appreciate going right now because I really want to build on what these last two said, because I think it's really on point. I've been an application developer most of my life. I joined Daghouse last year, and so I want to share two little anecdotes, one about the last year and one about actually the last hour that sort of illustrate the point, I think. One of the things that I've really found impressive about Daghouse is how focused they are on building a thing and building it, with some principles, with tools that everybody here is familiar with, but without being too wedded to a particular set of principles under the, behind the scenes. And it's not something that has been uncontroversial. The fact that, Web3 storage has been built on like these various centralized services is something that I think has been controversial in the past, but it allowed us to build this really scalable, really interesting, user-focused thing that solves a need. And I saw it again when Hannah gave a presentation about an hour ago about the proposed sort of Saturn-DAG house merger. The diagram that really struck me was it was a diagram of the two systems working together, and there were a bunch of red spots that were like the centralization. But then the next slide was like, how do we progressively work away from these centralized things? I think that has always been the way I've thought about building applications. You know, build the thing that interacts with the user, that solves a real user need, and don't worry about it if like it's not really implemented in the ideal way, if the backend doesn't actually work the way you want it to in the long run, because it doesn't matter if you get that underpinning right if it doesn't actually solve the user need that is actually going to make your thing blow up. So I like that philosophy, and I hope we keep it going.
Yes, but don't walk away from the other stuff. Just because you get that VC, that sweet VC funding, you still gotta keep building towards the thing. Yeah. Also, because that will scale better and make your product better.
You were first. Yeah, go on.
I'm based in Beijing, China, so I think most of you guys probably didn't experience this. I've seen like entire timeline on social media being censored. It's like 5 minutes ago, you were seeing an article, you've seen a screenshot preview, and 5 minutes later, you were seeing just a empty image block. It says, this article cannot be found. I've seen that, I think, 11 months ago during Chinese New Year, when some incident happened, basically the entire timeline just kind of disappeared. So knowing that there's some technology that's able to solve that is something really hopeful. I mean, it almost sounds like a cliche that people say hope is a nice thing, but I think for some people it's really liberating fact. But back to the technical aspect, it's just that like IPFS never felt like as reliable as it could be, because I'm not sure, like BSwap can be slow sometimes, and if the file is too small, synchronization can be slow. And if you really want it to be reliable, you have to rely on centralized pinning services. And that's kind of felt like defeat the purpose of using IPFS in the first place. And what if the centralized pinning service got censored? And although Filecoin was kind of like expected to be the decentralized pinning services, but my experience is like, as far as developer experience is concerned, like there's a big gap between IPFS and Filecoin, and that's quite like different from what I expected before coming to the ecosystem, because it always felt like a brother and sister project. It's supposed to be able to interopt. Like if I already have a CID on IPFS, I should be able to kind of pin that on Filecoin. So I'm not sure. So I was exploring this area. I was really hoping to improve on it, or see other people to improve on it, or collaborate to make it better. So, and ironically, at the same time, IPFS is like the storage is much over provisioned. It's like there's so much unused capacity. So, like I'm not sure technically if it's as straightforward as it's thought to be, but I hope one way or another we can make it better. Yeah.
Hi. I come from a much different background than basically everybody here. I'm a designer, probably the only one here. And anyway, one thing that struck me about sitting in various sessions and then just discussions here at Textile is about data permanence and about these timelines, long timelines, and talking about governance things, and that's also about timelines. The internet is really old. You talk about the IETF, WC, these are old things take time.
And also, as a designer, I've done loads of user research with loads of varied groups, from everything from genocide survivors to retirees to blind people. And one thing that kind of came to mind is one guy said, it's too old for us, talk to kids. And when we're talking about timelines, and you kind of, if you're trying to battle like these centralized systems and stuff, it's kind of too late, basically. So why aren't you talking to people who are just getting started, right? Why aren't you talking to kids? Why can't they make internets with IPFS? Why not? Why can't schools use IPFS? They got computers up that they're not using. They can control the resources. They don't got a lot of money. Why can't kids make web pages and put it on IPFS? They're good, they're creative, they don't care. And if you want them not to use Facebook, get them on something first, right? So that's my bit.
Oh, it is me. Okay. Great. Yeah, so I lined up earlier when some points were being made about you know, making IPFS ubiquitous, but also like thinking of building products and something specific that is useful to users. And I think that's something that we've been really bad about with IPFS, is thinking about, like, we think of IPFS as like, let's make everybody know about IPFS, and like we're gonna decentralize the world, and you know, we get around censorship resistant, you know, censorship, and can solve those problems. And none of my family is technical, and none of them care about any of that. They have specific applications and use cases that I think we can build products for with IPFS on the back end. And I think that when IPFS bridges the chasm, nobody's going to know that it's IPFS behind the scenes. I think, like, thank you. Yeah, most people, most of those 5.3 billion users Daniel mentioned do not know what TCP/IP is, and they should not know what IPFS is. Yeah. And I'm the last up here, so I guess anyone else on the panel got something else? Yeah. There you go.
Hi. We talked about how to bring IPFS to the mainstream. But what should we, in the first place, talk about is how to bring our values, how to bring the mission of decentralization into the mainstream. Look, I'm 19 years old, and none of my peers care about decentralization or crypto economics, or how these things actually add up to the civilization. Look, we are really going through a stage where we're no longer interested in the, you know, political aspect of this. I live in Turkey, and you can't even build an app and accept payments via Stripe. That's really bad. Also, IPFS maybe focused too much on building the technology, the infrastructure, while all we needed was just killer apps, proposing our values and just telling the story. I mean, you listen to all those talks throughout this week, and all I noticed, everyone is building the infrastructure. I think that's a point where we should, you know, maybe get a little interested in, because I personally made that mistake and spent years, maybe 7, 8 years, without building a product and getting any user feedback. You know, it really didn't interest me at all. But now we're in a very dangerous time where no longer of my generation is really interested in the political aspect, the ideological aspect of this technology. Actually, IPFS has a very deep philosophy behind it. When you start reading about it, developing on top of it, I mean, what is Kubo? what is IPFS? Ask that to a stranger on the street. Do you know what Steve Jobs said about Macintosh? He says, we're building this for your grandma. We're building this computer for the garbage man. I mean, if we, as technologists, as people who love building, we should bring value to real users instead of just focusing on, how fancy our new infrastructure, new SaaS, or new protocol is. Because ordinary people really don't care about these things. But people care about stories. People care about values. But once you connect with them, it's easy. But as the IPFS community or the rest of the decentralized web thing, the Web3 as a concept, as a word, don't really now, it didn't leave a good impression on people because of the crypto scams, etc. But I believe we should focus more about bringing the technology and the values to my generation, because you are all nearly 30-year-olds, but you are building products and businesses, or you're developing technology for my generation, and we will inherit this. So maybe we should try to bring more killer apps and invest more into marketing side of this before actually talking about the technical possibilities. Because we are in a point where the technology is okay. Now, it's maturing, but where are the products? I mean, what made World Wide Web a thing? Why people use words internet or web or browser? People adopted to these concepts because people use real products, and these things provide utility for people. So we should focus more about utility and storytelling part of this. Thank you.
Hello. I'll try to kind of describe the problem I think we have and some ideas how we can solve it, but I'm not sure if I'll succeed, but I'll try. So I think the reason I got really interested in IPFS quite a while ago, I think, was I was really dissatisfied how web was working. So so-called user agents, browsers, where I used to work before, they called themselves user agents, but they actually did whatever server told them. They didn't provide any agency. And IPFS, thank you. And it felt like IPFS was a thing where you can actually turn everything upside down and do that, because hashes and all this stuff, it kind of allows you to have this metaverse where you can own your own content and bring it wherever you want. But I feel like we maybe got a little too stuck on the hashes and forgot about the user agency piece, because those are means to the end, not the end itself. And I think sometimes we forget to emphasize all the benefits that it can bring you. Specifically, again, user agencies, that I own my data. In centralized systems, you cannot do that. That's why we have this set of apps that everyone recreates. All the big companies have this Office suite of apps. They don't interrupt at all. And you have to choose, like, how many messaging apps we have, and we have to have a consensus. Probably blockchain will do better in arriving at a consensus, which messaging app do we use to communicate with each other. Well, in the past, we had a protocols, and we were able to do those things. And I think IPFS is really well positioned to kind of address that, but we don't necessarily lead with that. And I think that is one thing we can address. Another bigger problem, I think, is if we do address that, if we unlock that piece, then the next thing would be like, why would anyone build an app for IPFS? Because right now, the way you monetize, you lock your users in a silo, and you really don't want them to go anywhere. If I'm building on this open system where users own their own data and I don't have any controls, and we need to offer some way to make them be able to support their work. I think there are some interesting ideas we can explore there, but I think we really need to think about how do we bring this platform, how do we build a marketplace where actually you not owning the users is for your benefit. I mean, there are a lot of interesting projects happening, but yeah, I think if we kind of lean more into that, we might be surprised how far we get really quickly.
Okay, I'm going to just, I'll be pretty quick. I wanted to tell a story of back when I were a boy. It wasn't all that long ago, but my friend David Diash showed me IPFS, and yeah, I added something on my node on my laptop, and then he managed to access the thing I had put on my laptop from a browser that went to like a gateway, and somehow it magically sucked the data out of my laptop. It found my laptop, I don't know how. It sucked the data out and then displayed it to him on a web page all the way across the world. And I was like, that's amazing. Have you, this is magic. And really, for me, that's what really excited me about IPFS. And I think that when you can do that to users and developers, that's what makes them want to use a particular technology. So I think if we did a bit more to just show that amazing superpower that we have, and it's not just that, there's loads of things in IPFS that are just incredible, and maybe we're just a bit too close to it to really appreciate it as much. But yeah, making the magic available for people to see, and I think people would jump to pick it up if that were the case. And also great developer experiences. If you don't have that, then it's not gonna work out. And that's all I wanted to say.
Oh, my turn? Yeah. Okay, thank you very much. Okay, how to get the IPFS to mainstream? I wanted to get started from my history. I joined the IPFS ecosystem from 2017, many years, and I come from China. I know all the history of IPFS and Faircoin, how to get adopted in China. So if I look at IPFS and Faircoin from now to the back, you can see the full history of how content addressable network or content addressable web get adopted in China. The first is last year, the NFT and the metaverse. NFT and metaverse is super popular in China, but IPFS is, everyone knows that IPFS is the fundamental layer of NFTs and metaverse. So IPFS is super popular in China, maybe beyond your imagination. I mean, not only Faircoin. I don't want to talk about the story of Faircoin here, but only for the IPFS, lots of universities and entities, even the government, they publish lots of research papers and survey and summary about IPFS, even give lots of risk, how to have better development in future, in the future, in the evolution of IPFS. As the most important is not only IPFS and not only NFT and metaverse. Another big transaction driven by the government is data economy. We build in China, in China we build the West computation and the East data. You know, the countries, the map of China country, the government wanted to put the computation in the West and put the data in the, and the data is in the East, close to the user. So with the traction of the infrastructure building, so IPFS and also Faircon technologies get lots of studies in China. That is point 2, the traction from the government. The third part is from the community. We have a huge big community in China of IPFS. And for example, we are building very useful feature of based on IPFS, or another implementation of IPFS is JAWS-FS. JAWS means the first paper money in the world. That is, we focus on the data versioning primitive. Data versioning could bring, bringing the data management layer for the machine learning and the AI. So that is the third traction of IPFS. It's machine learning and AI. We need to manage lots of data sets and models for the startups and the enterprise, and even for Web3 use cases. For example, Web3 Hugging Face. That is a very exciting area. We can build another standard or specification of IPFS. I think, to my point, I think the 3 point is very important in China. So welcome to come to China and connect to the China community to get the real situation of IPFS. Thank you.
Great. I wanted to just have one more thought beyond what has already been said. Actually, 2 thoughts. One thought was on the products question. Just leverage the fact that there's, oh, everyone's leaving me. Awkward. One thought is for a lot of the there's a bunch of groups that are building infrastructure or tools and systems on top of IPFS that can give you a bunch of facilities to go and build really good consumer products. So as an example, with Filecoin, you get a bunch of free storage. So with that, you could go and build we could do all of the data rescue stuff again, but now take petabytes. Because when we tried to do it last time, we were barely handling terabytes, and we heard about a few tens of petabytes, and we're like, oh man, how do we even move this? But now we can go data rescue all of it. And that would be a good adoption pathway. The other thing is you could do consumer products on personal cloud storage or things like that. So really leverage the tools at your disposal. Building a business and so on will help drive revenue flow that will then grow the team and so on. The second thing I want to mention is growing the community a lot. So from my perspective, the most important thing that we need to do is just grow the community by 10x. If we can do that in a year or 2, that will solve a ton of problems and will help drive a bunch of growth across the stack in a lot of areas that we need it. And in reality, there's an enormous amount of latent interest. There's thousands to tens of thousands of developers that are really interested in IPFS and the tech that it makes and in the sub-problems. These are really gnarly, interesting, fun computer science-y problems or really fun product problems. And there's a ton of people out there that already know the project that would love to work on those kinds of things. What we're missing is a smooth on-ramp for those folks, easier pathways for them to engage, and connectivity and connection to the rest of the community. Especially a lot of people can't travel as much, so maybe more of us have to do more traveling to more places. One example of that is the community in India. So I visited India and Phil Bangalore last year, and I was blown away by the scale of the interest there. I'll show you a little bit later a video on what happened last year and what's going to happen hopefully this year. But that community was ravenous for libp2p and IPFS specifically. They were like, oh man, we want to learn how to make all of these protocols. And these are deep systems, distributed systems students that want to learn and develop and grow and are super interested in developing open protocols. And so making a push in places like that and showing up in Force as a community and helping teach things, do workshops, help on board, and then maybe find pathways for them to support the work of various projects. That could help grow the community a ton. So, but I think that's one avenue. There's probably 50 other avenues that we could explore to grow the community.
We keep saying this word, connect. It's actually not a mistake that is the name of this series of conferences, plural. Why would you have a subdomain as complicated as istanbul2023.ipfsconnect.org? Is Doruk still here? Hey, can you run Istanbul 2024?
Yeah, he's in.
Perfect. So we perfect. So we did it here because the point was actually to connect for a much wider Web3 community that IPFS is relevant for. And we've had lots of stories actually of folks coming in being like, oh, this is where some of the protocol nerds hang out. Okay, cool. I can get my problem solved here. Connect, as it were. So this is a theme. And the other part is patterns, right? So loops, patterns that keep growing that we learn from. So we invested in putting together an open source framework for presentations. So it's some software, we run it, we can keep adding it. Anybody who wants to run a conference, let me know, we can deploy a domain for you. And that's something that we can keep using and we don't have to redo from scratch. Connect, connect, connect. We can reuse the speakers that are in the system and keep going. So my hope for 2024 is that Connect continues, we hand it on, and these are dark patterns from the past. I say that in a weird way. Barcamp, that many young people never associated with in the early 2000s, spread around the world. Somebody created a logo, did it in San Francisco. I did the second one in Amsterdam. And we took the logo and we changed the colors and we said, here's the Amsterdam version. That's been the design as well. This is the Turkish 2023 version. The 2024 version might get remixed again. Yes? Yeah. Come on down.
Here, okay.
We'll just keep fishbowling until they kick us out.
Very short question. Hello everyone, merhaba, hoş geldiniz. Is there any Turkish people around here? Okay, only one or two. So my question is, thank you so much for organizing this amazing event in Turkey, in Istanbul. But do you think that did you able to reach Turkish community?
Absolutely not.
So that's my question. I'm a game producer and I've been in the gaming industry since 2015, and we have lots of communities, like developer communities. So why you didn't reach to us that we can share the?
I literally didn't get paid to run this event.
Okay. If you for the next year, please. I will be a volunteer for you. Yeah, definitely. So okay, definitely, I will definitely help you. Actually, my gaming company name is Recontact. So hopefully we will recontact next year in IPFS. Thank you.
Amazing. Thank you so much. You should stay. You should stay. It's fine. You'll be the first shiller.
Right. Okay. So I think we're gonna wrap it up. I've proposed this session, and then I came up here and I was like, oh no, there's not going to be enough people talking, and that definitely was not the case. I know that Boris was taking notes while everybody was sort of talking about ideas, and some very passionately, some very cynically. But in general, most very positively thinking about the future of this thing. I mean, that's pretty important, and I've heard some remarks over here that I think that the future of the content addressable IPFS-driven web is there's a lot more in front of us than there has been behind us. So it's a really exciting time. I think this is a great opportunity to start thinking about running one of your own events in your own town. Juan mentioned that we need to get in front of as many communities as possible, and I really do think that the IPFS Connect model is probably the best way to do that, because it means people don't have to travel if they can run the event there themselves, and we provide maybe not a ton of money in terms of resources, but Boris has done the hard work of getting the websites and things set up. So if someone says geez, I'd really like to run an event, but I don't know how, we do know how, and we should just give them the tools and let them kind of take it away. And hell, I'll send them stickers and stuff like that. We'll probably all do that, and we'll sneak some of our own in there as well. But the resources are there and available.
This is awesome. IPFS Connect is great. I think we're really sorely missing this. I think it's going to help a lot. I might plug for whoever's going to remix the next one, considering adding a Node School style component or a Proto School style component as a workshop at the end, where or the day before, where you hands-on help onboard people and you build the thing or you work on something. That helps a ton to work through lots of problems, and you find good bugs that way and you help fix them. The second thing is huge thank you to all of the sponsors that help provide this. Because in terms of hosting more, we should route a bunch of public goods funding to all of the groups that are going to go and host more. So let's together commit to funding a bunch of these IPFS Connects around the world. So yeah, let's do that.
All right, speaking of sponsors and things like that, it's time for some shilling and community updates and things like that.
Yeah, so basically what we're going to do right now, Juan, thank you. Would you like to be our first shiller, or?
I can be.
Okay, we're going to be your first shiller. So basically, this is the community shill session. The diehards who stayed for the very end, we chewed through a bunch of stuff. There's a bunch of people who have calls to action. They have stuff to share. They want you to come to the 3 IPFS Connects that they already have planned next year. So we're going to do that. So anyone who has something that they want to share, keep it brief. I'd love to get a call to action. We'll make sure to get links from you afterwards. We'll send it out to everyone who came. If you can line up over here by Linda, if you want to come shill. And we can probably even we can plug in a computer if you need to as well. Come on down. Yeah, come on. Let's go. Let's go. Community shill time.
All right, cool.
We need a theme song.
I'm going to shill something pretty fast. By the way, this laptop is about to die of battery. So okay, got it. Great. So can I get screen? Great. Awesome. So here are some pictures of Phil Bangalore last year. There were about close to 2,000 people there. Look at that. Tons of workshops. People really excited. Oh man, there's way too many pictures of me. Man, okay. Anyway, ETH India. I'll show you the video. The video is super epic.
The people around there are so enthusiastic to make these new solutions out there, getting to learn new things, and it's crazy out there. I haven't expected this thing in spite of the bear market that we are seeing right now. So quite excited. I think the builders, this is non-impacted.
I think the energy is really great here. Even I've got around 23,000 developers applied for ETH India. That's a huge number. I've never seen this in any hackathon.
So 23,000 developers applied. They could only take 2,000. 23,000 developers applied. They could only take 2,000. That's crazy, right? So let's get in on this. Let's go have an IPFS Connect in India in two weeks. Who wants to remix one of these with me? I'm very down to try and grab a track within Phil Bangalore. We already have the space probably. We can grab a track within Phil Bangalore and create an IPFS Connect in Bangalore. But yeah, cool. So yeah, let's go do that.
I have no slides. Call to action. I've made this call to action many times, but if you want to make your content address things super fastly servable and retrievable, please maybe sign up for the Saturn private beta. Okay, that was the total product plug. That's my team. I got to do that. And then the other thing, though, I'm just still going on the conversation we just had. Did anybody ever go to a Rails bridge or a, yeah, right? These sessions that were designed to just teach people the basics, and like, you know, also like they were specifically designed towards bringing in a wider and more diverse group of people, which I think we could use a little of. Just a wee. Anyway, I think I want to do something like that, maybe in LA. Yeah, IPFS Connect, LA. Yes, come see the amazing city. It actually is really amazing. Don't believe the hype. Hollywood is not us. Thank you.
Oh, here we go. One mentioned Node School, and we literally built a Node School workshopper for our workshop for learning how to use W3Up, which is a new UCAN-based web-free storage thing. But the cool thing about this is this persists for ever, and it's a great, I guess, addition to the Node School workshoppers and things. And so these are cool kind of CLI-based workshop exercises. You select one and you get some information, and then you do the thing, and then the actual workshop verifies that you've done the right thing, which is, I think, really cool. But it means you can do it at home, you can do it in a class with lots of people. And so I used to do Node Schools in London, and we used to get a whole bunch of people together and work through these, and there'd just be people who are kind of experts walking around, and they can help out and stuff. And this is really cool for community building. That's what I wanted to say. Thank you.
Great, let's go. I'm just going to plug in the optimism one that you have, or
Hey everyone. So I want to talk to you a little bit about RetroPGF. Public goods funding is an area that we are incredibly excited about. We live in a world where more money needs to be going into public goods. What's exciting now is that there are entire ecosystems, and I know we focus a lot on the crypto ecosystem, but there are entire economies, internet economies, that are built on top of public goods, public digital infrastructure, and we are building new types of rails and new types of mechanisms to help fund the public goods that make all of this possible. We all know that open source is what powers Silicon Valley and any other kind of tech company today. The way that RetroPGF works, at least in the way that it was designed in the Optimism ecosystem, which is one such ecosystem that we're currently partnering with, is that there is a recurring source of funding, in this case sequencer fees from the blockchain. That generates revenues. Some percentage of that goes into a pool, a RetroPGF pool, which distributes rewards back to the public goods that effectively fuel this entire ecosystem. So anybody that builds applications, but also all the way down the technology stack. So if you're building libraries, if you're building dev tooling, if you're building any kind of core infrastructure or network protocols, including IPFS, those are the types of things that we ought to be supporting, and not just the top layer itself, the application. And so this is a feedback loop that we're trying to build with RetroPGF programs. In the case of Optimism, this is an incredibly exciting opportunity because they're experimenting with this mechanism in real time with big dollar amounts. The first round was last year, or no, sorry, I guess it's 2 years ago now, with a relatively small pool of $1 million. The RetroPGF 2 was 10 million. That was earlier this year. What's going on right now that we're helping with, one of the things that we're building is Open Source Observer, where we're trying to help measure the impact of different open source projects so that they can better allocate this 30 million pool that's happening right now in Q3 and Q4. But that's happening right now. There's about 30 million OP, that's over $30 million that's going to be distributed over the course of the next couple of months. But what's exciting and what is really interesting about this is that this is a recurring source of funding. that isn't going away. This is a commitment that they've made as a community to recur and continuously fund public goods. I would love to see these types of programs exist in other crypto communities, but well beyond that as well. Like everybody in society, in technology, building companies that are profiting off of this open source software should be contributing in some form to Retro PGF or some form of public goods funding. And I'm excited for experiments like this to demonstrate that this is something that can be very positive sum and value and not just, you know, something that we're comfortable free riding off of. We know that IPFS is used everywhere. So this is something that we're going to be highlighting in the Retro PGF programs in Optimism coming up. But, you know, obviously Optimism isn't the only ones using IPFS, and so we're excited to use tools like Open Source Observer to highlight that impact, highlight its value in the value chain of this giant, you know, software supply chain. This is what's happening now. Obviously, the sign up is already over. The voting is currently ongoing through December 7th. But
IPFS submitted.
Yes, and libp2p. And you'll be, you know, not surprised to hear that it shows up quite prominently when we actually do impact metrics and evaluating where it sits in the dependency tree of all these different projects. It shows up quite prominently. So we're excited to see the results of that and hope you guys follow along.
Cool. Awesome. Thank you. That was really useful because I needed that as a dependency in your minds to be able to make my talk go way faster. Cool. So some quick announcements. We're going to be setting up a foundation and a core fund for libp2p. There's a longer talk that goes into this in the libp2p day that you can go check out. I'll give you like the super lightning fast view. libp2p is a great project, came out of IPFS. There's an enormous amount of value across a number of blockchains that is being secured by libp2p. So a ton of blockchains all use libp2p, and you know their subchains all use libp2p. Adds up to about $300 billion worth of value, all secured by libp2p in the networking layer. Huge community, lots of implementers, and so on. Probably much smaller than the IPFS community. The IPFS community is much larger. And you know, in the past, there's been a set of funders, and this doesn't quite fully capture the whole picture. Different funders came in at different points in time. Recently, there was like this cool Celestia airdrop that happened. I think a lot of the IPFS folks also participated in that, which was a good way of like funding public goods. You just heard about Retro PGF. So libp2p so far has been like this amazing triumph of the crypto community coming together. This and adopting it. libp2p is not as big in the mainstream world yet, but it has that potential. But in any case, there's still a bunch of problems in the project. Kind of unsustainable public goods funded by a few organizations. We need like better structures and better mechanisms. Usually priorities in some other projects end up like driving that the set of implementers there. So like that's not fair to the project. And no good way of like doing community sense making on what makes sense to go build and scale. So we're going to set up the libp2p Foundation and the libp2p Core Fund as two separate groups to help with this. The foundation side is going to think about the long-term oriented governance questions, things about orienting the mission and vision of the project, oversees the spec and community processes, custodies brand, IP, trademark, and so on, and maintains some core infrastructure. The Core Fund, we're separating out because we want to have it be the first of many funds that many other parties can go start. So we want other people to compete with this, and hopefully, like, if other groups do an even better job, then that'll get replaced. I really don't want to get like the funding pathway and the long-term governance pathway mixed too hard here in a position where like suddenly like short to medium term concerns end up affecting long-term concerns, or you inhibit some better funding structure emerging because it's just not the thing that like the governance community is familiar with. And so I think that the coupling will enable a lot of experimentation. So what the core fund is going to do is going to, for now, because Lippy2P has so much adoption in the crypto space, we're going to start with a fund native to the crypto community. Maybe in the future we'll have a mainstream version. We are going to have this crypto native thing. It's going to do both proactive funding, like in grant-oriented structures, and retroactive funding, and it's going to deploy funding to teams and projects. So the way it sort of looks is like this. There's a set of funders. They fund the core fund. The core fund might fund teams and people. Those teams and people will then work on projects code and so on, and that will benefit the community. Key callouts, though. The fund can fund other funds. So if there's another fund that's going to do some other thing that like is even better resource allocation than the fund would do, great. The fund can like go and fund that fund. We want to create this like network of funds to be able to orient the capital to go to the groups that are having the most impactful, doing the most impactful work. And we hope that other funds will emerge and raise from the same funders, and then compete together to like figure out like what's the best allocation process. One of the things that I mentioned we're going to use both proactive and retroactive mechanisms. There's 3 mechanisms we're going to be using: DAO voting, GP voting, and RetroPGF. You just heard about RetroPGF, so that's the retroactive part. We're going to elect a set of batch holders in the Lippy2P community, many of them who are in the IPFS community, and they'll look at projects in the Lippy2P space and reward them retroactively. We'll have some application process and whatnot. Then for the proactive side, we want to push most of it to DAO voting of some sort. Probably not direct linear voting in terms of some DAO token, but really categorized by different stakeholder group. We want the implementers, we want the users, we want the funders, we want the long-term project participants. We want all of those people to elicit their opinions on these proposals to then decide which of these should we take on. We're still figuring out what tools to use exactly there and so on. And we know that some amount will have to be like decision-making of the fund, and that's what the GP side is. And we hope that that's primarily things like security response, time-sensitive projects, or areas where like we see that there's a lot of potential and the community isn't yet fully agreed, and so then we can take like a bet there. We anticipate that at the beginning we're probably going to do a lot of the stuff anyway as the community gets started, but this is the rough plan. And we need about $2 million and a bit to fund the project. To fund the core maintenance right now for continuity. So PL is contributing about a half of that. But we would love to raise 6 total per year to be able to grow the project. And we think that with all of those crypto groups, that this should be relatively straightforward to get to. We'll see. But my conception is that actually, if the Lippy2P community is able to raise a pretty large amount for Lippy2P, there's a lot of Lippy2P IPFS intersection work where this fund could actually be starting to fund some of the IPFS teams because they impact Lippy2P directly and they support Lippy2P. So just a heads up that about this. If you want to comment on the Lippy2P fund or whatever, you can join this Telegram group. All right, I will pause here and hand it off to Mosh.
Okay, so there lots of talk about these crazy new structures, like, is that even going to work? And I think I'm here to tell you an example that happened, and maybe we didn't know it. Let's see. Oh, okay. Yeah. Mine doesn't want to talk to... Oh, yeah, okay. All right, well, yeah. I am here to talk to you about one of these rounds that we did. It was a very early version, but and I want to tell you about how we did it and its impact on our community here. So if you try to go to Go IPFS, you can't find it because the implementation that was called Go IPFS for many, many years got renamed Kubo about 1.5 years ago. And the reason we did that is because if you squat the name of Go IPFS, that makes room for no one else to interpret what IPFS means, what it does, how it can work in different devices, environments, maybe different types of applications. So Kubo is the new name, and we said we wanted a Cambrian explosion of implementations. Well, What we did was create the IPFS Implementations Fund. It was a baby step towards moving from Protocol Labs sponsoring directly all of this work and incubating it in-house, paying engineers, hiring teams, to saying, hey, all of these groups have great ideas for how to build IPFS and IPFS components. Let's support them instead. Some of them are sitting right here in this room, and they walk amongst us. So if you fast forward just over a year later, and I had like a whole human child in this time, it worked. Like this is what happened. Most of this happened in the past year and a half. IRO, the curl work, and we actually pivoted halfway through and said it's not just implementations. If we want to meet developers where they are, we need to build tools that we need to build bridges to tools they're already using. So that's why the Unreal and Unity gaming engine plugins got built. Is Adam in the house still? Hi, Adam. Adam Grosky from 3S. Thank you. And so if you, and like Myceli was built to communicate with satellite devices, and it works. So this is all the cool stuff that happens when we take development and like the development side of R&D out of one single company and push the work and the funds out to the community, right? So this is the type of work we're going to do. I think we learned a lot of things through this process. We made some mistakes, certainly. We also ran a small retro PGF round that we also, we're learning a lot from. So this is what we're going to take to inform the designs of how we structure funding and coordination and collaboration in the future. Yeah, IPFS is great. We now have a lot of these sort of packages of value propositions that I was talking about. I would love to see us lean more into that in how we build, connecting from the software components, the libraries, implementations, to the applications that use it, to how we, how we structure the front doors of our website, documentation, working groups, like how you find other people who care about these things, even if you're not in the same company or team. All of this is going to inform how we set up and how we initialize the IPFS and libp2p Foundation. So a few key components of this, Juan's already mentioned: independent software foundations, open protocol governance. Several of the teams from Protocol Labs will become independent entities, and then of course public goods funding. So this is a really cool year for IPFS project and libp2p project as well. That's my shill. Thank you.
Great, so just following up there on Masha's last slide, point 3, independent teams that have been incubating with Protocol Labs moving out. Want to talk about one of those? That's IPFS Shipyard. I want to give a plug for that team. So again, after incubating here with Protocol Labs last number of years, they are moving out as an independent engineering team involved in the ecosystem, but working on many of the tools and implementations that many have used, and services and artifacts. So this is Specs, Kubo, Helia, Boxo, IPFS.io, Gateway, Amino, DHT, Bootstrappers. Those are the things that group stewards and are going to continue to do that. The intent is to hold a high bar for the maintenance and operations of those things, while also getting to run hard at making the next billion websites faster, more resilient, and more open. So Protocol Labs, kind of like we already saw with libp2p, has already agreed to generously cover a lot of our yearly expenses for next year, but we're also working to broaden the funding pool. So we are looking for a small group of early financial supporters. And also I should say that as part of graduating from Protocol Labs, that also means we have more flexibility of some of the work we take on. So we will be, as some great knowledge experts and experienced folks in the community, we're going to be available to be hired to collaborate and work on things that maybe that you need done. So you can learn more about this at our scrappy website, ipfs-shipyard.org. And again, we'd appreciate any support, feedback, or referrals that you may have. So that's thing number 1. Kind of related to that, I also want to announce the IPFS dApps working group. IPFS Shipyard is partnering with Liquidity from the Ethereum community, and hopefully other groups that care about having front ends that are truly decentralized. especially with the advent of better user connectivity. This is a use case that IPFS can absolutely nail, and we want to see that happen here in 2024. So we're still getting the details for this set up, but the meeting series is posted on Luma. So this is IPFS-DApps under Luma, and it's on the IPFS community calendar. And there's a Telegram group at IPFS-DApps. So yeah, good times. Thanks a lot.
All right. Is the USB-C recommended here? Yes, connect. Sweet. Okay. Yeah, so I'm just here to show the links. Steve didn't. Just kidding. But here's the DApps working group. It's awesome. Luma/IPFS-DApps. Here's the IPFS-shipyard. Scrappy, I don't know if he didn't want to show that, but it's there. There's a URL so you guys can see it. It's recorded. Also wanted to plug the Helia working group. So we run this once a week. I think I'm actually supposed to be running it. I think I'm supposed to be running it right now. Thank you. But yeah, a little bit, I think 6:30 p.m. What is it? Right now. So welcome to Helia Working Group. You are now all in session. Sorry, guys. Just kidding. But no, one last thing. If you weren't in my talk earlier, I hosted the room hostage so that they would scan this and go +1 a Chromium bug. So I think you need an account, but if you have not done this, it's here now, and I'll just wait 12 more seconds. 10. Everybody's done it. Please, please. We went from 5 to like 17 today, so let's get it up there a little bit more. Okay, I went over 10. Thank you very much.
Hello, hello. So one of the teams that is pretty close to both the LPTP and the shipyard team is ProbeLab, which is looking into what are the things that look like that when you look under the hood. When things are working, but not exactly the way you expect them to or want them to. So it's another team that has looked into lots of IPFS things, LPTP things, but also outside of those protocols into Ethereum things and other things. And we found this happening quite a bit, and we argue that we should take things to the next level where we provide more performance evaluation rigor in order to fix everything so that water goes through the pipe. And if you want to learn more about this, I'd like to invite you to a bar nearby where much of the shipyard team is going to hang around for some of tonight to have a drink. So yeah, come around, hang out with us. We plan to be there at some point between now and later tonight. I don't know if people want a break or not. Would people prefer to go for a drink just straight after this, or an hour later? An hour later? Yeah? Yes? Yeah, an hour later, an hour and a half later, yeah. Okay. So around 8 p.m. or maybe a little bit before, several of our team members are going to be in a bar which is called Craft Beer Lab. It's, yeah. Some people chose me to choose the bar. I don't know why they did that, but yeah, so that's where we're going now. It's about 10-minute walk from here. Put it in your map of choice. It's called Craft Beer Lab. I'll send a link to the Discord channel for IPFS Connect. And yeah, whoever wants to join and have a drink and learn more about this and what this team is going to be doing in the near future, I can tell you there. Thank you.
Hello? Hello? Is there any Chinese people here? Okay, thank you very much. Is there anybody have been to China and have been to Chengdu? No. Oh, thank you very much. Okay, I want to give a quick introduction about the Jiaozi FS. Jiaozi, simply pronounced with dumpling Jiaozi in China, but Jiaozi is a paper money like this. It's the world's first paper money. It's born in Chengdu. We have a Jiaozi museum in Chengdu for financial museum in Chengdu. Okay. Basically, what is Jiaozi FS? Previously, we wanted to build an IPRD database, but we found that it is not easy to find the market profit, so market fit. So we get started from a fair system that is good for machine learning pipelines. Jiaozi FS is very simple. You can think of that as the Git plus fair system, or Git plus IPFS. Oh, sorry. Jiaozi. Okay. For many years, we do lots of activities on the CODA corporation. You can see the different generation of CODA corporation. The latest CODA corporation is Git. But for the data corporation, we have distributed system. We have for the past 10 years, we have very mature distributed file system like internet application, internet components, many huge data size on the distributed system like Google File System and Hadoop ATFS and Amazon S3 and IPFS. But what can we do data corporations to? We do the data corporations with copy and paste. And data is not only standalone. Data always with the code, and the code always with the data. So the current solution is, the famous one is Git, large file system. But it doesn't have many features of IPFS, for example, CID features and content addressable storage. So we wanted to build Git-like data management server and poetry indexing and content addressable storage for data versioning. Okay, this is a simple architecture. I want to skip it. What is the use case? We can build the data versioning. Over the data versioning, build a Web3 Hugging Face. And we can build data versioning for modern data teams and platforms. Like DevOps, we can build data ops. And we can build versioning for end-to-end machine learning pipelines. And we can leverage the IPFS, CID, and the data container mechanism to build the infrastructure for data economy. Okay, that is what I wanted to share about the Jiaozi FS. Next step, I want to share the roadmap. Sorry? Okay.
Call to action. What's your call to action?
Okay. So the monetize and the roadmap is one way is go to Web 2 and one way is go to Web 3, as you can see in the picture. Call to actions is I want to call to contact us and funding us and support us. I have a proposal to IPFS Connect in China for next year. And you can not enjoy the new technology about IPFS, but also the beautiful scenery and beautiful food and delicious food. Thank you.
Well, we crowdsourced an after party because we didn't have funds to sponsor one. That's amazing. Thank you so much, Yanis, for that. Craft Beer Lab will post it, tweet it, telegram it, and all of those good things. Thank you so much for everyone who participated today. We've got tons of follow-ups. Thank you all for supporting us. And I hope we can basically put it in the name, IPFS Connect. We've heard LA and Chengdu for 2024, which is amazing. I have a back channel link to IPFS New York that apparently has some interest as well. So we're going to collab, we're going to follow up, anyone who has links, we want to send them out, we'll put them on the website, make sure everyone gets them. All of this is recorded, so as Juan always says, thousands of more people will see the video content of this as well. This is a strong start. Give yourselves a hand of applause. Thank you for everyone who supported us, and that's it. Thank you, team. Thank you, co-administrator. That is it. We're out.